am I live? I don't know. How do I check this thing? How do I check this thing? Can you hear me? Can you hear me? Hey, you can hear me. Pog. Okay, so that's working. Let's make our announcement. I am live. Skyzar says, hey, what's up, Skyzar? You're a Twitch notification viewer. Welcome, welcome. I appreciate you. Is it huge again? Hi. It's so nice to see you all. Thank you so much for tuning in, Skyzar, Isidiosh. We are in and we are going. We're making our announcement still. You're before the announcement. Oh. What are we gonna do? This is gonna be compiler part 50. This is the bicentennial episode. Zarias waves. Hello, Zarias. Welcome, welcome. Ooh. Okay. Skystar says that's sus. What's sus? What? Haven't done anything. Hail. What? Zarios says, did we fix the arguments in LensorOS? What? Which arguments? A lot has happened in LensorOS. We can check that out. Yeah, it's here. There's been a lot. Zarios says function args echo I'm good lens, how about you? How about we just let's do it. I should have it right here. So I did fix it. And I got it working eventually. And I was able to, we're now able to use C++ in user space. What did you guys want? Echo hello world. Echo I'm good lens, how about you? Do you remember what was the problem? Oh, yes I do. The heap, libc heap was broken, I fixed it. I go, hey. We did it. Here, I can even... IRC client win. Zaria says, so the implementation was wrong. Yeah, here, let's just, I don't mind going to check it out. LensorOS is in user libc standard lib. Basically, somebody noticed when we were looking at malloc, first of all, that we never set this previous to null putter, even though we have a free putter from the free list, and it may have a previous pointer, and we don't want it to be in the free list once it's on the allocated list. So the allocated list and the free list were intermingling, which is very bad. So that was bad, first of all. So we set previous to null putter. There was a off by one error. There was a greater than. That should have been a greater than or equal to that we fixed here. I don't think that was coming into play, but it is a little bug we fixed because we weren't getting enomem. And then we were doing the same thing here where we have to set the previous. And then in free, we're doing the same thing where we have to set the previous. Just some linked list shenanigans in the libc heap that I had to debug. because we ended up being able to, by the way, the reason it wasn't printing things out isn't because the code wasn't running, it was because we didn't call fflush, which we figured out later on stream. We just had to call fflush because for some reason it's calling like abort versus actually libc fini or anything like that through exit. So Arias says, oh my. A little bit. It was good though, it was good. Intercept, where are we at? Basically, with Intercept, oh yeah, and then I was able to get C++ working in user space by writing our own libstandard C++ implementation and fixing echo build to include fno stack protector, fno exceptions, and fno RTTI. fno stack protector was really the biggest one. These are just kind of for clarification and consistency with the other CMake style of LensorOS. Isidur says, Lens, you and Sirraide trying to figure it out. Keep the curious programmer in me alive. Thank you, guys. These streams are awesome. Thank you. I'm so glad you enjoy. Because sometimes it doesn't feel worth it. But when there's messages like that, I know it's worth it. We had a pull request from a Discord member, I believe. Indecent Labs, are you somewhere around here? Somewhere around here. They were talking in the Discord today or something. I can't remember where. So much happens. Oh, there they are. There they are. Discord member. Presumably it's the same person. I guess there's no reason it has to be. Hells151, hello guys. What's up, Hells? Yeah, we have a pull request on the compiler. Let's check it out. It basically, oh yeah, some fixes in Vim syntax highlighting. I haven't updated the Vim syntax highlighter at all. So that's a good thing that this is updated. So we can see that we now have to do, which just basically says to do fix me xxx and note are highlighted. That's fine. I'm totally cool with that. There's a int comment line, starts with a semicolon, ends with a new line. I assume this is regex. Contains int to do. Contained. Okay, I don't know how this works. Presumably this works. Zaria says we do love Vim. Nashiara says Vim tax highlighting. Fix that for you. It looks like we've gained special. I don't know what this is. Intercept special. Is that a backslash? And then a character class, which contains, oh man, I'm kind of lost here. I don't know the Vim regex this well. What are all the double backslashes? I see this is an escaped quote and single quote, but what is the T, the NR? I don't really have to know to accept the pull request. It really just, I'm going to assume it works because I don't use Vim. Someone will complain and fix it if they use Vim. When are we adding games to LensorOS? As soon as possible. Write them. Port them. That's it. That is a major goal of LensorOS, is like to play Doom. And I want to have like the classic solitaire and pinball. Why not? It's a long ways off though. I mean, we just need them written, but I have to write like the underlying everything. It's not an expansive PR. We can see that it's +11 -5. It removes semicolon from the list of operators. That's probably very important because semicolon is not an operator. And then we have special being special. So what is this special match? Can we do like regex matcher? Okay. Just checking things. I don't see what it could be referring to. I'm not exactly sure what this is. Presumably it works. I guess I could clone it and test it in Vim. I can try. See what the hell happens. Neutrino says escaped strings. Ah. That could definitely be it. What do I have to do? I have to leave this branch and go to a new one. Okay. Which is from another remote, which means I'd have to add a remote, or I'd have to clone into a new... I don't really want to do that. Can I view the diff and just apply that? That'd be hilarious. It's fine. Basically, we replace comment line with this stuff. We replace operators, and then we do this. I'm going to do it by hand, folks. Editor, Vim, which is called int, syntax, I presume. Okay. This goes here. Cool. Yes. Things. Sure. Okay. How do I even do this? Vim. That didn't go well. Anyone remember how to do this? Do I have to set the current syntax? I have to set the file mode, which is ftDetect int.vim, which is star.int set file type. Do I need to set file type equal to int? We have plugin on, indent on, detection on. Very interesting. The question is, did it work before? Not a command. Okay. So we can do file type detection on. Why can you not tell me what the... I don't know how to use Vim. I don't use it that often. I just use it. I know how to edit text. I know how to move the cursor around very rudimental. I can't even speak. Rudimentarily? Is that a word? Rudimentarily? Rudimentarily. I'm not even gonna try. And I don't like Lua. Yeah, not that. Well, that didn't do what I expected it to. Skystar says third one. I don't know what that refers to. Third one. What? There were no changes. Boink. In number, comment line, comment, operator, special, in string, string. So what if we don't do, well, special is probably escaped strings. I don't know what it's doing here. So this is a backslash. So this is \n, \r, \, quote, and single quote, and \t. Okay, I'm starting to get it now. So this just matches escape sequences. That should be fine. There's also type is another one, which is interesting. Did I screw up this? I don't know what I screwed up. So let's think about, I don't even remember how to do this. Is there a README in the Vim thing? Add the following to your vimrc. So maybe I don't have that in my vimrc anymore. Where's my vimrc? Vim. So, okay, I found it. Ah, yes. That would be why. That'll help. That should help us. Hey. Poggers. Okay, now can I don't even remember how to open a file. Sirraide says, yup. Hey, Sirraide. Welcome, welcome. We're merging a PR. I fixed some things. Not in the PR. I didn't want to look at byte array. I wanted to look at strings. Nice. We've got some string syntax highlighting. Beautiful. Okay, so all I have to do now, since it works, is merge this bad boy and then switch back to the proper things. We could also add type, but I'm not gonna be a stickler there. Perfect. Looks good to me. We will merge this bad boy. Because it works, it works. What do I have to do? That's right, I just made the changes myself, ironically. Don't want to do that. What we want to do is merge this into main. Yes. What's up, Sirraide? Thank you so much for tuning in. How is it going? You doing well today? Looking good to me. And we welcome a new contributor into the codebase. Welcome, Indecent Labs. Okay, now I have things to do. Because I believe this is going to affect, well, it may still just be automatically mergeable. Yeah, we should just be fine to rebase onto main still, and nothing should go wrong because we didn't edit the editor folder even, so we should be good. Cool, we can still rebase. Beautiful. Oh, yeah. Okay, intercept. Let's do it. That's not the right build command. That's better. Beautiful. array-param as a test still doesn't work, which is something I noticed, even though we're no longer failing to pass arrays as parameters. It is now failing because we have a variable reference kind 33, aka .param. So it looks like this is during code gen. Otherwise, we would have printed out the code gen dir. So it says the web server proper is done. Ayo, pog, pog, pog. I was refactoring file loading and path resolution, shutter, which is almost done, but right now I'm taking a break. After that, I need to update some more stuff to work with the refactored codebase, and then I'll finally be able to try and see if it compiles. Oh God. It's one of those. I'm so sorry. Well, you have a great environment in LensorOS to come back to. It's getting way better. C++ in user space works now, BB. It's beautiful. It's a real clusterfuck. Even thinking about how the libraries interact with each other starts to hurt my head. But, you know, it's going well. If I keep thinking of what you said, where it's like, just imagine they're all one library, and it starts to work in my head. And I'm like, oh yeah, I'm just calling another function in another file. But it's like, wait, this is in another library that isn't. So then wait, it's so confusing. And then I had to stub out libm, so that's probably going to break things as soon as that happens. It tries to use libm. So yeah, no floats or doubles yet. In C++. In C, we should be able to get away with it. It's a mess, and definitely no exceptions, by the way. So it says nice, but once the server is done, I'll have to implement a dynamic web application, if you will, and after that, I should really start working on a templating language that is not just HTML. Oh no, what is a dynamic web application? That sounds horrifying. What are we doing? Unhandled. I can't type. Variable reference IR instruction. Okay. Oh. Binary expression left bracket. This is a subscript. So what are we looking at here? If the left-hand side is a variable reference, and it's a... Yeah, I don't think this is right. Hold on. So we have the... Why can't we just use... Interesting. Are we here? We are there. Okay. Why is there a check for this? What am I missing? Sorry, it says, in this case, pages that are generated dynamically rather than static content. Oh, I get you. I get you. Neutrino says, are you planning to have that bad boy run on the edge? I'm definitely not testing it on edge, lol. Should work, though. IE is not supported because screw that. A legend among men. It's so true. I think you should support as many as is convenient, or you're willing to. If you're not willing to, I don't think you should have to, or even think about it. Why is there even a check here? Why do we check that this is this? Does it matter? If one... Just checking. What should it return? What did we do? No instruction mnemonic using default for sub. Interesting. Okay. So we had a .param. It's been lowered. So we have a .param, which is a pointer to integer 2. An array of 2 integers. We reference array. Is this a local ref? Let's look at the actual test. So array is a static ref. Sirraide says that check is because I don't know if it can deal with a var ref referring to anything other than a variable. Like a parameter. So if we have array, then this left-hand side, a dereferenced xy, is this correct? Well, yeah, a parameter is normally not a variable. So what do we have to do in case of a why do we have a variable reference node in that case? What's the AST look like? We have a unary at of x. Well, that's interesting. So xy0 gets us the first integer, and then we dereference it. Yeah, this makes sense. Could be done in some cases, though, if it's a stack param, so maybe that check is obsolete, though. I'm thinking that's what's happening. What if we just add our parameter? That makes the thing go away. It returns 0, which is not correct. Pointer to integer to copy into racks. This is just a static ref at the time of the function being instantiated. Copy 3. So what we're doing now is just a copy for changing type. So it's now pointer to integer. We load 5 to get an integer. Then we return 6. This looks fine. So maybe we got to check out var ref in Cogen backend. I don't know. What is the, what would it be? We don't really have var ref. So let's look at the code. Let's look at the code. Foo takes integer, returns an integer, an array, size 2, and of integers. Okay. This may be integer array, or it may be array of integer. I'm not sure what order that's in. Doesn't matter. Sub-0 RSP. This is a little worrying. Aren't I on Microsoft? There needs to be more than that. Am I crazy? Locals total size. Oh. I don't know when this stopped happening, but apparently it did. I think this is shadow stack space. Well, it exits with 0, which is surprising. We have 16 bytes. This makes more sense now. Are you compiling with optimizations? No? Should I? Still doesn't work. It's not really right. I think we can fix this up now. Sorry, it says no, just checking. Because optimizations might remove the shadow stack in some cases. I see. I wonder if I'm putting the shadow stack in a new place. That's probably what I'm doing. Hold on. Yeah, it's probably fine. But yeah. It's probably fine. Because the shadow stack's probably, I don't know, but then why were we subbing 0? See, then that doesn't make sense for this local function. Well, it does because there's no locals and we subbed 32 before we called it. Interesting. Yeah, I think it's fine. I'm just doing it at a different space. It's the same end result. It's just a little wacky. Did that work? There we go. Because it's not subtracted here, it's subtracted here. Very interesting. Then we push the base pointer sub 16 from it to push whatever's 16 off the base pointer, which is, I don't even know. What is 16 off the base pointer? Array? It's an interesting one. So we do, yeah. That's the lowering by the x86-64 backend, where we're copying from array into 20, which is a local, and then we pass a pointer to this to the function we called. With the pointer to the integer, we then move it into racks, dereference itself, and then return it. Which should work. You would think that this would be fine. Why is this returning 0? Did we ever store? Are we storing into the wrong place? So we move 69 into DX. Compare DXCX. What are we doing there? Why is there a comparison? Ah! Sirraide, we need that warning so bad. Ah! Oh my god. Okay, turns out I forgot how the language works. You need to assign things. You can't just test their equality. Yeah, that helps. Oh my fuck. Oh my fuck. Okay. It makes sense for that function to allocate 0 bytes because it doesn't have local vars. Yeah. And its only parameter is allocated on the stack of the caller. It does make sense. It just weirded me out to see sub-zero. Sub-zero temperatures. Oh my god. I still can't believe that was the issue. Okay, well, we fixed the test, so we fixed that. That's fantastic. I'm gonna say a non-zero check. I mean, technically I could put optimize. Maybe the next thing you should do is add that warning. Definitely. Did I break things? I think I broke things with that. If I leave that, just gotta check. Did I change the wrong thing? Is this not the right spot? What am I changing? Frame full, prologue. Doing a 0 check here breaks things? I see what I have to do. I did a little wrong here. So what if we don't do this? Yeah, okay. So basically I have to say if not optimize, do it. Or if f local total size, do it. I just got that a little bit funky. There we go. So if we're not optimizing, emit this no matter what. But if we're optimizing, then if we're optimizing, this will be false, which means that it'll move to try this thing to see if it's true, and it only if this is true will it then emit this thing. Okay. Okay. Let's omit that warning, huh? I'm trying to think when would be the ideal spot. So within any root or block, if the parsed expression in the root or block is a comparison, it's discarded, so why are we doing it if it's not the last one in the block? And I think in the root we should warn about it no matter what. Well, no, because you may want to return the return value of a comparison. And you wouldn't want to return an assignment. So if it's at the end of the program or in a return statement, yeah. We good. Okay. Let's commit this little didgeridoo. What did I do here? What do we have going on? We have yep, we just added parameter as a possible variable reference. And then we fixed the yeah. And then we fixed the test. That's right. We didn't actually have to fix anything. So let's separate these. I know it's kind of messy, but we'll do it anyway. We're going to say cogen allow ir parameter as a variable reference. They may be a variable reference. Parameters may be stack allocated locals effectively of the parent stack frame effectively. So we sometimes refer to them as variables. There is probably a stricter condition we could check for parameters to ensure they are actually stored on the stack or whatever. I think that's fine. That's a little messy to read. Parameters may be stack out of the parameters. We sometimes refer to them as variables. There's probably a strict Sure. I don't even think a stricter check is necessary. I'll let the may do a lot of work in there then. Because that'll always be true unless codegen is broken. That's true. So it would just be a stricter check to ensure correctness. It wouldn't necessarily be a necessary check. If not optimize or f local's total size. Optimize zero-sized stack frames. Sure. Tests. Fix array-param.int. Those aren't assignments. Okay, that should help us a lot. Yeah. Very cool. So let's add that warning. I think we could do it in the type checker. And we're going to say for each child, if we type check it and it's proper, right? Then what are we going to have? What are we going to have? So we have node should have a type. Okay, now, and we basically just need to make sure. Also, to be honest, that check should really go where we omit sub add perhaps, like if either operand is an immediate zero, yeet the entire thing. True. It would just, yeah, that's totally fine. I mean, we can do that we just haven't done it in immediate to reg because it's not guaranteed that all instructions do that. So we just haven't broken it down. But you're right. We should just have that check probably even above these, where it just says if instruction is sub, immediate is 0, get out of here, or add. If multiply in 1, right? We can kind of do all that, and then we should just omit. I guess we can't even omit skipping there, can we? Anyway, where are we at? Basically, we want to detect when we have an equals instead of an or equals in the root. Let's start with that. Let's start with the root, just to make it easier on myself. Okay. And then basically we're going to say if node does not equal vector back and node kind is equal to node binary and node binary operator is equal to token equals error. Jesus. That was a rough one. That was a rough one. An error ILO in lieu of a warning is what I meant. Okay. It might even make sense to make that a warning instead of to make that an error instead of warning. I see what you mean. Because some people don't look at warnings, you know. Like me. So let's just do this and say comparison at top level result unused. Comment out. We should say, did you mean to use I think we can use token type to name or something here. String. Did you mean colon equals? Did you mean to assign using blip blip? Are you ever planning on changing the string representation of token colon equals? No, but if someone wants to like change the syntax of the language by changing the tokens, I think it should propagate through the whole program. I agree, it is ridiculous, but if someone wants to make colon equals the rocket ship operator, if they really want to, they can, you know what I mean? It's not up to me. I don't know if that works currently either, but you know. So now we should go back to this param, put it back to what it was. Thank bejesus. Okay, this will save me so much stress. That's gonna be so nice. Okay, now we need to do the same thing for blocks. What are your blocks? Okay, same thing. Comparison at top level of block. Okay. Also, it might be shorter to write comparison result unused. Did you mean to use colon equals? It's true. Yeah, it's probably, as a user, within block probably isn't that necessary. Comparison result unused. We already give the source location, which means they should be able to go here. By the way, one thing I wanted to test out. Because this should work. I haven't used compile in so long. What do we get? Okay, new shell uses a semicolon. Compile does not. I think compile supports like a POSIX. We're nearly there. Okay, now it's just I'm running it from the wrong place. Okay, very pog. See, CMake prints spaces at the end of lines too. It's not just me. And everybody loves CMake. Okay, this is pog. So this is what I wanted to test. you can see that with Emacs compile, our error actually gets highlighted and recognized as an error because of the error keyword. And we can now just press enter, and it takes us exactly to the position where the error is, and we can go, oh, this is meant to be that. I think that's very pog. Very pog. Okay. Standardized error message format, go brr. Sea Lion can do that too. That's awesome. Intercept works. Sea Lion integration. That's what we're going to market. What are we doing? We have the type checker changes that we just implemented. That's pretty much it. I'm okay with putting those up. Doing numbers. Sema. Add. Make it an error for top level. Ooh, hold on. Okay, continue. I can, yeah, make it an error for top level. Comparisons that go unused. This, oh God. This is super common because equals is not the assignment operator. We should probably add a test to make sure that error fires and only when it's supposed to. I mean, yeah. Yeah. What would be a good test? I mean, what would be one where it fires when it, like, what would be a common one where it shouldn't fire but it might? Did you mean assign? 1. When it's returned from a when it's returned from a program, we've already accounted for that, but just to make sure it works. Okay. We basically just need a top-level comparison as a result, and this should return 1. What should... I don't know if that's standardized. We have false standardized as 0, so we can do that as they're not equal. That should be fine. This represents a returned comparison from the root. 69 equals 42 now, apparently. Good to know. Thanks, Lance. Well, 69 is the answer to life, the universe, and everything. So it makes sense that they're the same. Returned comparison from the root. It should not trigger an error for a top-level comparison. $69 420. I. A. I like I got turned into A. Oh, I'm a child. Okay. Did you mind assign 2? This represents a comparison in the root that should be an assignment. It should trigger an error for a top-level comparison and prompt and present a "Did you mean this?" prompt. Beautiful stuff. A is an integer 2. I guess we can do something like this now with array literals, which is pretty pog. And then I'm going to say, actually, I want to assign a at 1 to add a at 1 plus 1. We may need to parenthesize that. We'll see how it goes, parsing wise. And this should return 69. So we're going to return add a1 plus add a 0. How nice. Sirraide says, no, the precedences should make it work out. Okay. I was just worried that this would see this, and we're going to dereference that. Otherwise, that'd be a parser error. Oh, I agree. I think there might be errors in the parser. That's still array-param. Beautiful stuff. This should error, by the way. Imagine if Unicode had 69,420 limit instead of 65,536. Pog universe moment. So it says, no, the precedence of at is much higher. Okay. Yeah, so this is yeah. So we won't do the binary because it has a lower precedence. So we'll do it last. Even if we, yeah. Okay, so we have did you mean 1 now, which does give us the error. Did you mean 2, I mean. Did you mean assign 1? Works. And hopefully returns 0. Does return 0. Okay. Is there any other... Yeah, we need to do the locals. This represents a return comparison from a block. It should not trigger an error for a block. For a comparison, that should be an assignment. Cool. Technically, we could put all of these things in a block to better test that if it's the last one, everything's fine. And then we need, did you mean assign 3? And that one worked. Now we need, did you mean assign 4? And I need to go, did you mean assign 2? And do this. This represents a comparison in a block. That should be an assignment. What's their limit, Sirraide? I presume billions or something. I was reminded of that harshly a while back when I tried wchar-t for a program involving emojis. No, don't do that. Sirraide says 1 million something IRC. The maximum apparently is 10 FFFF, or 1,114,112. Oh god, I mixed U plus and OX some lamau. All the characters we ever use are in just near 1 million? Pretty much, yeah. I'd say that's accurate. I use about 100 characters consistently, maybe 200. Okay, did you mean assign 4? Beautiful. So if I now run the tests, oop. A lot of emojis are composed that way as far as I know. So it says there are also combining characters that you can use to make new chars, so that's that. Yeah, once you get into like BiDi chars and combining characters and diuretics, it's like you don't want to do any of that. I promise. What did we call them? Did you mean assign? They all passed. Fantastic. Perfect. Bunch of new tests. Whoa. Did you mean assign tests? I forgore. Oh boy. Cool, that'll help a lot. What are we doing? What was I working on? What did I do? Arrays as parameters now works, right? Oop, that's not what I meant to do. What have I done? There we go. Okay, it does return 69, so we're good there. That's very cool. One thing that it would be very nice to be able to do is all of this on Linux as well. So let's start figuring out that, shall we? Where's a good size for this? What do you guys feel is good? Maybe here? Sorry, it says, but how are you going to test it? WSL, I think. Oh my god, I almost just leaked my IP. Jesus. I'm so glad I remembered before I clicked those 2 buttons. Whew. Oh wait, no. I removed it. I hushed the login Ubuntu thing, so it doesn't leak it anymore. Pog champ. I'm still just gonna get it ready out of habit. Okay. Isidish says WSL2 is a pain. That's why I use WSL1. I also don't know why Ubuntu/Debian does that. Yeah, it's really annoying. IP cable, CCNet, thank you so much for the follows. It's like if you foresaw the future. It's probably a Debian thing. Yeah, most likely. Do I have a Linux build? cmake-g build Linux -G. What am I doing? I don't really care about -G. I care about -B on here. It can be Unix make files. -D. Isn't there the... Here, hold on. Let me just do this. 9.4. What am I doing? -LH. Wonderful. Build testing, Ccache. Build type, install, native opt. Okay, we should be fine. I don't think there's anything I need to do. Sorry, it says we can hear the bells, Lamau, terminal bells. Yeah, that's WSL. I don't know how to turn it off. Do you know? I hate it. It's every time I press backspace. It's every time I... You know what I mean? It happens a lot. I set up Zish on WSL. Yeah, that'll work. That'll do it. We just need to build. I love my flashing missing program message. It is really beautiful. I love how easy it is to build. What have I broken? I don't, I see why. So I need to cast 1 to a size T here. And here. And here. 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 There's seemingly a lot of places that I messed this up. This is weird that I don't... Why are I'm only getting these in the older version of GCC? Because I've used GCC 10 dot something here. 10.3. Sorry, it says integer literals in shifts. Shifts in shifts. Yeah, it's not the best. But it has to be done for bit selectors, man. What are we doing? I built it. So now we build it. Beautiful. Now we can do... What do I need to do? Basically, I just need to pass it everything I do. There. And then we can do tests. Also, you missed my message on how to pronounce Debian earlier, I think. Also, the E in Debian is pronounced like the E in tests, not the E in deviant. Debian? That just sounds wrong. I'm going to continue saying Debian. Debian sounds like... that doesn't even make any sense. It's Debian, I guess. Debian. I'm going to call it Dubian. Yeah, so it's Dubian, is what you're saying. Dubian. I got it from now on. I got it. Don't worry. Dubian. Why is... Okay. Sorry, it says it's a proper noun. It doesn't need to make sense. That's fair. These damn beeps. This is interesting. I'm still confused. Why do I not get these? Please. Does the pronunciation of Arkansas make sense? For that matter? If you replace the last S with a W, it makes sense. I like Dubian. Does the pronunciation of English words in general make sense? Not at all. So... tests. array-param. Ah. Okay, we're not going to clean first because WSL is slow. Well, we can still fix this. We don't need it to be... Also, hey, it works. I did just need to clean first. So, pog. I did it. And now it should be fast. Wonderful. So, parameters in register x86-64 says... The backend does not yet support determining SysV ABI specifics for parameters. Sorry. That's not ideal, right? And where is this? This is in parameter is in register 1789 from here. So basically, what does this say? Oh God, that's bright. My eyes. Ugh, I'm going to scoot back. Okay. We first define a number of classes to classify arguments. Okay, so we have some amount of arguments in this function, and we have a given parameter index, which refers to a parameter within the current function. Cool. Did that really happen? Is that really a quote? Is it you? Says, this is why I like not speaking. It's true. I can't believe 1793. Ah, 1789, I see. I don't know what's wrong with me, man. Though I suppose if 42 equals 69, anything is possible. Oh, God. I'm good with numbers, I swear. We first define a number of classes to classify arguments. So we're going to need to classify this parameter. Integer. This class consists of integral types that fit into one of the general purpose registers. So do I want to set up like an enum? I think I may want to do this. Something like this, yes. We're going to call this sys5 argument classification. We'll call it a class. That'll make much more sense, less wordy. That's usually called a register class. This is fine. Argument class, register class, x87 up. You ever just know that you're never going to use any of this? No class, okay. So no class should probably be different from invalid. Oh no. Oh no. This is in parameter is in register 1789 from here. This is in parameter is in register. 1789 from God, 4K. Oh, that's amazing. That's amazing. Oh, I'm so dumb. That's incredible. I'm just looking at 1793, 1789, clearly. Okay. These are all rather self-explanatory. And we're basically gonna need... I don't... Okay. Emacs freaked out there. It just froze. So it says, oh wait, I know why you said 1789, Lamau. You were looking at the wrong line. Look to the left of the red text. What? Oh! So I read this and then jumped up here. I'm a genius. What did I do? Okay. What was the class? I feel like we're just gonna need to classify here. Okay. Okay. What am I doing? So we have to classify these arguments. Arguments of types bool, char, short, int, long, and pointers are in the integer class. Okie doke. So I guess I'm gonna need a param type, parameter, a parameter type. And this is going to be type canonical of parameter type. I guess, yeah. And then I can say if parameter type is equal to t integer. So it says, still, this is further proof that Lensor's native language is actually written from bottom right to top left. Diagonally, of course. Which also explains why he added BiDi text to light. That's right. I need it, yeah, I need it backwards and diagonal. Parameter. Don't we have is integer as this? We have type as pointer. We can do this. If type is pointer parameter type, then class equals sys5 reg class integer. implement sys5 class. Okay. Or type equals t integer. I think I can just do type here. I don't really need to freak out like this. Or type is equal to t byte. Could not classify argument according to blah, blah, blah. What is the argument that we're trying to classify? Function. It's an array. Okay. So we have we have integer to do, type is integer or something. Cool. Imagine only needing 2 lines of code to determine the argument class, shaking my head. TNT Master. Hi, what's up? What's up, TNT Master? Thanks for tuning in. It's good to see you again. So what else? Arguments of type float double decimal. We don't have those. Arguments of type, we don't have those. Arguments of type, we don't have those. 60 of arguments, we don't have those. Terrifying. Okay. We don't have those. Again, our array should be treated like structs. Do we have, are they talking about structs here? I don't feel like... Because this is an SSE intrinsic, right? So it says yes. So when they say M64 or M128, they're talking about SSE and stuff. The leasing 16 byte structs are passed in 2 registers. Yes, I just don't know where it says that. Okay. Oh, okay. Okay. It's a whole separate thing. The classification of aggregate structures and arrays and union types works as follows. If the size of an object is larger than 4 8 bytes or it contains unaligned fields, it has class memory. Okay. So we've learned things. And it's basically that if type is array or type is struct, we should have like a type is aggregate. Do we not have type is struct? That's a little funky syntax. Okay. Type is array and type is struct. Then please, if type, so what does it say? If it's greater than 4 8 bytes, that's 32 bytes. Okay. If a C++... Okay. To do. Check for unaligned fields. If a C++ object has either a non-trivial copy constructor, not applicable, I'd say the C++ object stuff, I'd say. Okay. If the size of the aggregate exceeds a single 8 byte, each is classified separately. Each 8 byte gets initialized to class no class. Okay, that didn't go well. I'm going to use regular. I thought I was. I'm going to use regular mode just so I can do this. You know, that's something I didn't think about. That I'm not in C++ and I just loaded C++ mode. That's probably what just occurred. Yeah, that's better. Yeah, it's still broken a little bit. I broke things. Anyway, I just need to load CTS mode again. It's fine. I'll just deal with the comment stuff. Each upright, so we kind of have to recursively do this, don't we? So if it's an array, we have to classify the base type. If type is array type, classify base type. If type is struct, classify each member. I hate this. So what happens when you pass like an integer, like 3 int64t's? Then a post-merger cleanup is done. Okay. Maybe just read the entire thing and then think about implementing this. Okay. I'll move on. Each field of an object is classified recursively so that always 2 fields are considered. The resulting class is calculated according to the classes of the fields in the 8 byte. If both classes are equal, this is the resulting class. Each field of an object recursively so that always 2 fields are considered. What? Okay. We have to split it in half because you might be able to shortcut it. Well, yeah. We have to split it in half. Whatever. If they're both equal, this is the resulting class. Okay. If one of the classes is no class, those result. Okay. If one of the classes is memory, the result is the memory class. If one of the classes is integer, the result is integer. If one of the classes is blah, memory, otherwise SSE is used. Then a post-merger cleanup is done. If one of the classes is memory, the whole argument is passed in memory. If if the size of the aggregate exceeds 2 8 bytes, and the first 8 byte isn't SSE, or any other 8 byte isn't SSE up, the whole argument is passed in memory. Okay. So this is saying split it up each. Each 8 byte is classified separately. So we only ever need to consider 2 at a time. By the way, these are just passed in registers, right? Are structs ever pass in registers? Can we say integer here? Like, does this ever happen? This does happen, right? Classified as integer. Anything below 8 bytes, I think. So yeah. Yeah, 8 bytes or below. So if it's above 32 bytes, we go, oh, that's easy. It goes in the memory. If it's below or equal to 8 bytes, we go, oh, that's easy, pass it in a register. But if it's 16, 24, 22, if it's one of these amounts of bytes, it gets more difficult. So I think I'm going to have, if type is array, what's this? We should classify the base type, right? I feel like that's something sensible, which means we probably have to make this all a thing. Yeah. sys5 classify argument. Why not? Okay. What less than or equal to 8 bytes? Yeah, because all elements is going to have the same class because they're of the same type. Beautiful. Maybe put this here. On 8. Anything 1, 2, 4, or 8 bytes can go in a register. Coolio. That's not what I want. What do we get? class does not equal, okay, could not classify argument according to SysV ABI, sorry. So we get invalid because of here. So if type is array on type, classify base type of array. So I don't even know what to do here. Base class equals classify, blah, blah, blah. On the, so this is going to be an array type, which has an array here, has an array of, which is the base type. With the base class, what do we do with the base class? I don't even know what it means when it says two fields are considered. What does this mean? What two fields are considered? Where do we get the two from? Do we just split it in half? Do we get the first two? I'm kind of confused there. Do I just, like, I don't know. Do I need to get the, like, two? Just copy it? But then they're going to be the same, which means I would just return it, which doesn't make any sense. What am I supposed to do here? I have an array of, shouldn't the size matter? So first of all, if the array size is 1, we can just return the base class. I don't think that would make sense. That's overcomplicating things. We don't need to sort. We don't need to get the biggest. It doesn't say that. It should be all specified right here. So we can classify things this way. We can classify aggregates this way. In which case, it says each is classified separately, each 8-byte. I don't know how this makes any sense. It goes each 8-byte is classified separately. So we just have to go whatever the first 8 bytes are. Can we fit those in? Like, I don't get this. Obviously, we can pass things in registers that are 8 bytes, but why? I don't get it. Let's go to Godbolt, the compiler explorer. Also, did you see, did they say Yacht is in here? Yacht is in here from SerenityOS, which is very cool. It's not working yet. You have to pass -s, I believe, question mark. This just isn't Yacht. Yeah, I don't know what this is, because Yacht uses FN. It's not perfect yet. It did work, though. But yeah, Yacht is actually in Compiler Explorer. It's very cool. And I recommend checking out Yacht, SerenityOS. Very cool project. Where was I? CPP2 is there as well, as far as I know. Very interesting. A lot of langs are on there. Intercept when? We probably just have to make a PR and make it work. What am I doing? SysV. I believe GCC x86-64 will run on Linux, so when we pass an array of 3 things, you can't really do that in C, so the best we can get is a struct. I know this is C++, it's still the SysV ABI. X, Y, Z. Sure. What am I missing? So this is pushed on the stack. I'm trying to figure out what's happening here. We have racks into RDI. Oh, this is Intel. It's all backwards. I can't really make this bigger, by the way. I would zoom in if I could. Add a function that declares a foo and calls square. You can click on the A. Oh, Jesus. Okay. This is crazy. This is passed on the stack, so we sub 16 off the stack for A, but then we move into RDX and racks, and then we move RDX and racks into RDI RSI. So this is stored in registers. So we call, would we move into RCX? The stack pointer, crazy, okay. So this goes on the stack. So it seems like as soon as it's 16, larger than 16 bytes, it goes on the stack. If type base size is less than or equal to 16, how do we do this? I have to split it up into 2 arguments. That's what C clause said. What? In the post-merger cleanup. Okay. If it exceeds 2 8 bytes, the whole argument is passed in memory. Okay. If an aggregate exceeds 2 8 bytes, the whole argument is passed in memory. You have to load the first 8 bytes, pass it in the first register, and so on. What does that mean for the classification of the argument, though? What is the argument classified as? There's no classification for this thing is split up into 2 things? What? Do I just return the thing, the base class? So even though it's larger, otherwise, aggregate is less than or equal to 2 8 bytes passed in 1 or 2 registers. I don't know if this makes any sense. So it's almost like we could just do a size greater than 16 here. Otherwise, return integer. We can try. Implement sys5 class 1. That's integer. Okay. And this says parameter is in register. So we can say if class does not equal sys5 reg class integer, return false. Otherwise, return true. We definitely made it further. We made it all the way through code gen. Oh. Heyo. It was a YouTube notification. Why? Oh, I try and turn as many of those off as possible. Avi Shadow, Bearded Superhero, Kyle Wiggs, thank you so much for the follow. I appreciate it. So we have 69 stored into 5, which is a copy of 3. We have 420 stored into 10, which is the offset of 1, the subscript of 1 into the array. So we have 69 and 420. We load 3, which is, this is before lowering. So we try and load an entire array and then call foo with that loaded array. And then in function lower. Okay. Do you have any favorite Linux distro? No, I don't have enough experience. I've barely used any. I would have to actually use multiple and try them and try and do things, you know what I mean? Psychedelic7, thank you so much for the follow. Well, also, first time chat. Welcome, welcome. So, I'm going to do this a little differently and say to do and then this will just not do anything. Okay. Lower. When we lower a parameter, okay. MouseSX says, hello, this is the compiler for Intercept? Yes, it is. Yes, it is. CG call conv Linux. So lowering a parameter, can we store whatever we just did? Weren't we just, where am I crazy? Okay. So we're gonna say if parameter backend flags I was just saying we could cache something in IR parameters. I could get a little messy though. I don't think I want to do that yet. I'm just going to reclassify things. And then put a to do. So basically, we don't need to recompute this, but it's not a big deal. So we can cache it as soon as we have somewhere to store it. Beautiful. What just happened? Void lower. Oh, I did a return true here. Perfect. Okay. Now we say, give me, why is this all messy? It's indented the wrong amount. Hello? Is that tree sitter doing funky things? Sorta. For some reason now my C mode thinks it's C++ and things are indented 4 spaces, so everything's a little bit broken. That's how it should be. It's driving me a little bit crazy. So it says, I was taking a look at LLVM's call lowering, but it's rather inscrutable. Much like the word inscrutable. We're doing really good. I'm feeling good about this. Switch. Why is it? My indentation is just fully broken, so I'm going prog mode. I'm pissed. I'll do it myself. We have a case. Well, what are we switching on? We're switching on class. We're going to have a case sys5 reg class integer. And then we're basically just going... It's broken in prog mode too. Jesus. Just so broken. Why do you do this to me, Emacs? Okay, it still just thinks, yeah, it's just like, oh yeah, what if we just did that? That's where everything should be indented to. Fucking dumbass Emacs. What are you doing? So dumb. Does that fix it? Okay, that fixes it. Having this all stupid long line condition. Tree sitter. I'm doing it. I know it's minimal, but I'm doing it. Emacs is just correctly telling you that four spaces are superior. It's definitely fucked up. And we're going to say if type size of type less than or equal to 8, then it just goes in a register. I don't think there's lowering that needs to be done. So if it's greater than 8, we actually need to put it into 2 registers. I don't actually know how to do this. What does the instruction become? The parameter. Sirraide says, I'm more than happy to help you write a Clang format config, lol. That's a good idea. We should do that. Okay. So it says, I don't know all the settings myself, but we can just check the docs. Yeah, we'll figure it out. Today, I realized that everyone is a knife holder if you try hard enough. I like that, Rondi Dub. So it says, you know, LLVM docs tend to be jank sometimes. Recall the docs about Clang command line fakes. Yeah, they're awful, is one way to say that. And basically, we would like to say that instead of this parameter, how does this even work, Sirraide? I don't get it. I don't get it, Sirraide. If we split it across 2 registers, how do we actually load the fucking thing? I don't get it. How do we lower it? We have a parameter, cool. We can classify it, cool. But it's not actually, how do we lower it? We can't just make it a register. We can't make IR registers. We don't have that. You know, like, how do I make one thing stored in 2 registers? This is insanity. What am I looking at? Oh my god. GNU. Align after open brackets. Align, what is this? What does this change? It changes nothing, okay. There is a million things. What? Oh my. See, this isn't... There's something that's... There's so much. This is terrifying. This is cool though. I'll keep this in mind. So it says, yeah, that's all the options. That's a bit too much. I would maybe not recommend that until you're more familiar with it. Yeah. It's definitely a lot. Sirraide, I really don't get this at all. How do we break something into two things? Sorry. We don't support structures of this size for the SysV ABI. Make the struct bigger or smaller. What if we just do this, right? Sorry, we don't support structures of this size. Make the struct bigger or smaller. How about that? What about it? There's two ways I can think of, and neither sounds particularly nice. Whatever is doable, because I just want to get this working on Linux as well. I don't like the complexity of this stupid ABI. It's not a stupid ABI, it's just fine, it's more efficient, it's whatever, it's just implementing it sucks. Which means that the onboarding is harder. Either leave the IR parameter and add a flag that marks it as split, or add another instruction. If we mark it as split, how do we store both registers? We can mark it as split. Rewrite all calls to the function as well as the function signature. No. To what function? Oh, you're saying the function itself. The latter is what Clang does. So you're saying we'd have to go into the actual function, but then we have to insert another parameter? But what does the parameter refer to? Like the element in the array, or then how do we actually do that? Because we're going to be, in our code, accessing the array. So then when we access a variable reference of the array, how do we deal with that? That's why that's option 2. Even if we mark it as split, right? Because we can go like instruction backend flags. Why? I feel like I've enabled that 8 times. Or equals, and then I can probably just do this. I think there's a way to do this. IR set flag or something. So this takes in an instruction and a bit index. And then we can just say sys5 split. That sounds cool, Sirraide. Thank you. So if we set it to sys5 split, what's the plan then after this? Because it just says byte size cannot be converted from register size from 979. Then we have to handle that everywhere. Are you saying we have to go through and handle like, oh, in copy, in load, in call, in blah, every time it might be a split thing, we then have to load it from 2 registers and custom and hard code that? Can we do it when we like lower a load? How far into code gen did we get? Ah, very far, I see. Is it like literally the first instruction? Why is it not emitting anything? Well, tells you what? If it's a split argument, then it's either a struct or array, right? So passing is easy. The problem is array-parameter tells you what? I don't know what that tells me. Presumably allocated in memory by the caller and passed through as a pointer. We gotta do all this. Catalina fucking wine mixer. I think we can just create a local variable, store that value in it, and then replace the IR parameter with a load from the variable, perhaps. So the SysV ABI, in which we split things into registers, we're going to then specifically create a local variable to store the 2 registers. or 2 to store the parameter value in a local var. Mandax, thank you so much for the follow. FAQbar, Sticks Color, thank you so much. I appreciate it so much. I can't believe I'm already at 337. That's insanity. What is classification 8? That's memory. Do we not break? We break. Why is it not working? You jerking my chain? I'm confused. Parameter is in register. What? Okay, I'm getting it now. Unlowered parameter instruction. Yeah, we have to replace it with something. In this case, why didn't I replace it? Wait. We get BP. It's less confusing if you read my messages in order, just saying. Well, there's a million of them. How am I supposed to know where to start? If it's a split argument, then it's either a struct or array, right? There's not much you can do with either of those except subscripting, member access, loading, etc. So it might be possible to handle all of those separately. Oh wait, I just realized something, so passing is easy. The problem is the our parameter tells you what? I think we can just create a local variable, store the value in it, and then replace the parameter with a load from the variable, because I think an our parameter is only used to 1, refer to a thing passed on the stack, or 2 to store the parameter value in a local var, so that should work. Have I explained what I'm thinking of well enough, or is there something that's not clear? Well, all you just described is everything we did for the MSWin thing. It's all this code. That's not what I'm confused about. Passing things in memory is fine. How do we store and load things from that? And what do we do when it's here? Handled 9 to 16 byte sized aggregate types. What the fuck do we do here? I don't know. For memory, I'm pretty sure we need to do something like this, though I don't know why it's not working. Because I don't know how we have an unlowered parameter instruction. In register allocator, like I don't know what's happening here. So we should have already lowered, which means this should have happened, but it isn't. Well, that's a separate thing. Why doesn't this work? I think you did do a great job of explaining what you were talking about, Sirraide. I do think I understand you. Why does the register allocator... Why do we have a parameter fucking instruction? Stop. We shouldn't have one. Where is it coming from? Print. after lowering. We still have param. It hasn't been lowered at all. That's very annoying. Okay. So basically, allocate a local variable, store the IR parameter into it, 8 bytes, i.e. 1 register at a time. Create a load from the local variable, replace the IR parameter with the load. That's the TLDR, lol. Okay, I'm still confused. I'll try and think about it. Why is this not happening? This is so annoying. We just don't get here. But before, when this case didn't exist, it said, hey, handle lowering of fucking blah blah blah. You're just not gonna... Does it think it's an integer? There's only 2 fucking places we can be, and I don't think we're in the other one. If we are, it makes no sense. Naturally. We just don't see it at all. Why are we not getting here? This is so annoying. It just stopped going here. Does anybody know what the fuck I did? Yeah, it just doesn't... We don't lower anything, apparently, anymore. We never get here. No problems. What the fuck? Is it the stupid canonical type bullshit? I swear to God, we should just store the canonical type in the fucking instruction. This is ridiculous. The amount of bugs it causes. It's so annoying. Okay. See, we don't... Is it this? What is it? Do we not need this? We'll get rid of it all. Just doesn't want to do anything. Because it's a pointer to integer 3. So it's expecting this thing to be done on the stack. So it's saying parameters not in register, which means it's a pointer. So we just need to do this, right? It's kind of recursive, but I think this is necessary. You can probably do that in sema/codegen. Right? Well, that made it fucking work, apparently. So we copy 3 as a pointer to integer. 3 is a copy of 2. 2 is a pointer to integer 3. We pass it in memory here. Okay. Canonicalizing types, that is. I see. It's probably worth it in CodeGen when we set the types of the instructions to set them to the canonical type. That way we don't deal with so much shenanigans surrounding it. So, allocate a local variable. So when you say allocate a local variable, you're talking about in foo's stack frame, we insert an allocate here. Store the IR parameter in it. Sirraide says, yeah. Store the IR parameter in it. Create a load from the local variable. Replace the IR parameter with the load. I'm just gonna start. I don't see the larger picture, but I trust Sirraide, and I'm sure he's not leading me down a terrible path. Hopefully it clicks in as I go. So I need to make an allocation for the type of this parameter, right? Insert instruction before. So we do an allocate. What am I looking for? So we literally need to do this, right? Allocate a copy of something. Which makes a pointer to that thing, an allocate, stores into that thing from the copy. And the copy is the value. I think we literally need to do that. So what do we need to actually allocate a copy of? We can't use that because we have to do custom store logic. But we can learn a lot from it. I'm going to do this and then look back. Setting the size is something that we can learn. That should be good. And I think in this case, we don't want to make a pointer copy. So about the .clang format, do you prefer aligning declarations or not? E.g., if you have int x3 and vector int y equals 0, should the equals line up or not? No. I mean, not automatically. It should stay if I do it manually. I know clang format doesn't do that, but in most cases, no. I wouldn't do that. I would do it if I'm doing like int x equals 0, int xy equals 4, int y equals 0. You know what I mean? Int yx equals 3. If they're just like one off, I would, but it's not a big deal. So it says, well, that's not an option. Yeah, it's either always or never. I would do don't align it then. So we insert some alloc, cool or whatever. We now need to insert stores. We would like to store into the alloc. Is this a mem copy? No, because it's from registers. The value is going to be a register. First 8 byte. Something like that. Well, lowering RA hasn't been done yet. So we just need to set this as the current instruction, right? I'm confusing myself here. Okay. Is this lining up at all? I still don't see the bigger picture. What are we copying from? What are we copying from? We are copying from you might have to figure out what the registers are here and now and use IR register. You know that's awful, right? There's like no way to know that. I hate SysV so much. We don't know how many argument registers we've used. We could have had 2 things passed in 2 registers each on the stack, 2 16-byte register, 2 16-byte structs passed in 4 registers. So it could be the 3rd parameter and be in the 5th argument. Yeah, we somehow need to determine that. That sounds impossible. It doesn't sound possible. This is dumb. I hate calling conventions so much. You guys love it so much. Oh, so much better than Windows. Windows is fucking 10 lines. This is some bullshit. it is possible to determine that from the signature. So you're telling me we need to write a function that goes through and classifies each one and determines all this bullshit about whether it's in one register or two, and then just returns the argument register that something would be stored in? Is that what you're saying? That's some bullshit. It's really dumb. This is so stupid. It really is. Oh, this is annoying. SysV is so much better, so much simpler. Oh man. Okay. That's a bunch of stupid boilerplate out of the way. Oh my Christ. Did I do it? Sirraide, did I do it? So we get the register index for an argument by getting the offsets by adding consecutively in a loop until we get the parameter index, the argument register count, which is either 2 or 1. So overcomplicated. Yeah, I think that sounds about right. Okay. So overcomplicated. It's just everything here feels so needless. It really does. So now I get to make an instruction. First 8-byte IR register. We'll do 8-byte 1. Why is it not? Of course, because these are below everything, naturally. Okay. That's none of those, right? Parameter index. Are you mad? You size to, oh, I don't care. This is tiring. Oh my God. It compiled. A little worrying. We don't actually insert these instructions, which is kind of a big, no. And then something here has to actually be replaced. So I think we have to say, not this, but instruction kind equals IR store. then all this stuff except for the last bit. Replace param, blah, blah, blah. Okie doke. Byte size cannot be converted. So we didn't set the type of something. Oh. Da-da-da. Okay. A store instruction should not have a type. Is that us? That's probably us. What do you want about? Our store gets the size of the value type. Eight byte 1 T integer, 8 byte 2 T integer. I don't think anything cares about the type of a store. Still shouldn't be, it should be a void. Why are we trying to load 0? 1. There's 1. So I didn't actually replace uses, is I think what's going on. Right? What is even happening here? So the param gets lowered into an alloc, which doesn't have the proper type at all. So this needs to be an and pointer. Okay, so now we have a pointer to integer 2. Copy 3. 3 is an integer, yes, yes. Store into 2. 4, store into, okay, yes. Now we need to get the incremented address. Increment address. So we did this down here. We get an immediate and then an add. And yeah, the allocation should be a pointer. You're using LLVM here. I didn't see that before. I'm not using LLVM here. Offset immediate is equal to 8. I need to add 8 to this. I think the address type is fine. Well, no, the address type needs to be the same type that it's a pointer to the base type. So this would be like a pointer to integer. I don't think that matters. I think we can just have it be an invalid type. A bit of a type mismatch in the IR is fine. This is by the back end. Okay, so we do that. We add 8 so that we can then use address. And we insert all of these things. We're getting there. There are some differences, but it's close. It's just, yeah, it's a regular IR. They're all different. It is, of course, inspired by the others. We don't shun all knowledge and go, I don't need to know anything. By the way, Stixcolor, thank you so much for joining the Discord. If you are new here, be sure to check out the links down below and check out this Discord where we have a ton of fun, talk about programming and all sorts of things, linguistics and, you know, all sorts of things. So be sure to check it out. And there's announcements every time I go live, so be sure to check it out. And then check out my YouTube if you want to see previous VODs. Be sure to subscribe there to never miss a stream again. So I think we're trying to use one, which is like a removed. I don't think this exists anymore. So we need to actually. So store into 2, 4. 4 is an integer. Store into 9. 9 is add to 8. 8 is 8. Okay. Reference an array, allocate 16. Store into 11. 1. So we're now storing from the wrong spot. We now need this to be the allocate. So instead of like replacing the current instruction, do we like actually full on replace uses and then remove? Well, that seemed to go better. Something is still going wrong. I'm not sure where yet. 979. IR copy operand size. What's going on here? So we have allocate 16, register 14, register 13. These are probably just arguments. What are we at? Copy 3. So we copy register into R2, store into 2, 4, which is just the parameter. Okay. We have a register 13 at 5. This becomes copy 6, which is an immediate 8. So we just have 8 in 7, add to 7, allocate 16, store into 10, 2. What am I getting wrong here? The first 8 bytes from a parameter register are stored. The second 8 bytes are stored. Why is this happening down here? Like it feels like everything's split up. Ah, that's definitely going to confuse things. I didn't replace this with its own instruction. Whoop. Let's, hold on. One more. That makes more sense. Okay. So we allocate, which we insert before param. We're using insert instruction before in all of these cases, just to be clear. So we insert an allocate. There should be 2 registers inserted. And they happen to have copies made from them, sure. Store into 2, 4, which is the register. That's fine. 8, 7, add to 8. See, technically this is a pointer to integer. Can we just do that? Address type. See, this isn't equal to instruction type. I think this should be address left-hand side. Is this guaranteed to be an array at this point? No. So if we just do a pointer to the left-hand side and type, we're probably going to get a pointer to pointer integer. Yeah, it's going to be real weird. We need a pointer to the base type if it's an array. Really, we just need a pointer to integer. I don't think I need to freak out about this. Because it just needs to be an 8 byte, no matter what. I'm curious as to where it's actually failing. Oh, not that. Apparently, before it even starts. 979. I feel like I went here already. It's an IR copy operand byte size. So we're trying to copy something that is 0. Copy 3. Copy 5. Copy 7. Ah! Aha! Immediate does not have a void type. It has an integer type. Do we set that down there as well? We do. Everywhere except for where I had it. Okay. Interesting. Interesting. Okay. I have a feeling it's random. What is foo actually supposed to do? Why doesn't this work? We allocate 16, we get 2 registers, we store. So we could probably do this more efficiently. if we split these up. Because we don't need to insert this until after we've stored the first thing, calculated the second address. Then we actually need that register. So we allocate 16 for an array of 2 integers. This does make more sense now. So we now store into 2, 4. 4 is a copy of 3. 3 is the parameter, I would hope. Allocate 16 integer 2. Okay. Why doesn't this work? Allocate 16 is then used to store into 11, 2. We're probably just going to end up copying. See, we need to emit a mem copy here, not a store into. But store should be lowered Interesting. So everything up until here seems valid. Where we end up with the thing on the stack having the two parameters properly used. And we may actually need to emit both of these 8 bytes before everything so that we don't actually emit over them. So I think I actually have to move this back up because basically with register allocation, we need to make sure that it doesn't overwrite these registers to do anything. So we may actually need to do these first before the allocate. Okay. But yeah, you can see it'll keep them alive as long as needed. So when we store into 9, 5, 5 has R2, R2 hasn't been used. And when we store into 6, 3, 3 is in racks, racks isn't used until just after. Beautiful stuff. Register allocation. So, okay. Where's the load happening? Okay, okay. What is instruction type? I don't know. What are we loading? The allocate. What happened? Load 6. Byte size cannot be converted into register size 16. Did we emit some code yet? Am I just mistaken and it's not? Where's the actual code being generated? It says, I guess we deleted it and we're not generating anything. RIP, because it's an ICE. So the fact that this load is an integer 2, we then refer array. That's just a static ref, nothing to do with anything. We then have 12, which is allocate 16. Store into 1210. What is this? Why do we have this extra allocate in here? What's going on? So we try and make a local copy of this array. We try and copy a pointer to integer out of it. And then we try and load from that pointer to integer. So we're making a copy of the array and storing into it. This is before lowering. Allocate a copy of the array. Why are we doing this? Allocate store into. Where does that come from? Allocate store into. Also, I missed a first-time chat from Justofi. Is your language somehow related to functional lenses? No. The language isn't even named anything to do with lens. That's my name. Lens. Parent block. If parameter is in register function. I guess this won't work because it's not a singular parameter. It's the entire call. I see why it's done that way now. Jesus Christ, this is a mess. So the allocate should probably just be 16. By the way. Okay. Where's this allocate and store? We only do that if parameter is in register. Interesting. Handle sys5 register classification 1. That's much cleaner. Okay. Oh, Pog. Do you see it, guys? Do you see it now? Do you see the answer to life, the universe, and everything? Oh, Pog. That cleaned that up. What have I done? This is such a mess. IR fix up for this specific backend. I don't think that's that confusing. Lower needs to be a static, just to make sure. Yeah, okay. Parameter is in register. We are actually calling parameter is in register, right? We are, okay. Neutrino says, I just stepped away for a second. What happened to all the allocates? I fixed it. We were making a copy of a copy of a copy. So I eliminated the copy chain and we now just use the pointer we're given. I don't think it's right. I'm pretty sure it's broken, but it does work. Basically, what this does is we copy the argument we are given to change its type, and then we dereference this type into an integer, and then we return that. The pointer we are given is to everything, this stack. Neutrino says, oh, yeah. I'm still working on it. But the pointer we're given to is actually this allocate up here for the foo. And pass through. But this should be passed in 2 registers. Right? So it's not perfect. And why does this happen? It's because we make it a pointer type. So the parameter is in a register. The parameter is in a register. So if we do it like this, then we do a whole copy. We don't want to copy the whole thing. Aad Pex Twin Dong. Thank you so much for the follow. What a name. And first time chat. OS Frog compiler dev on Twitch. That's right. So somehow this is wildly important for lowering to actually undefined reference to main. Beautiful. Reg size from bytes in 1250 16. So we're loading this thing, but that's an integer 2. And then we ref an array and allocate. Why do we allocate a copy? We allocate a copy because we think it's just in a register. So this should just store the thing on the stack, and then we use that. All right, I was gone for a couple minutes. Where are we at? Well, we can now pass things in memory in Linux just fine. I'm pretty sure that's all working. However, parameter is in register returns true even when the thing is split across 2 registers. The argument is 10 now, looks like progress. Yeah, we're doing much better. However, here's the problem. Byte size cannot be converted into register size 16. Here's the problem. We're doing a bunch of copies of copies. So, right? In calls, I'm pretty sure we're passing a copy of the array to the call. So we're not setting up the call properly. Sirraide says yes. So this is incorrect. We need to fix up that. Second of all, Sirraide says, I see. Second of all, we're making an allocate to copy from the 2 registers. So just pretend that we have 2 parameters and 2 registers, right? We have 2 registers that were passed. Sirraide says, yeah, pretty much. So we allocate, we store into 6, 3. 3 is an integer, which is a copy of the first parameter. So we should now have the first 8 bytes stored. Then we add 8, right? We add 8 to the allocate, the address, which you're also adding 8. Nice. Yes. So then we store into 9, 5. So we now have stored the second 8 bytes. Yeah? Then we load the allocate, and that is actually what is used here. So we just made a copy on the stack and loaded it. But why do we need to load it? Why can't we leave it as a copy on the stack, right? Is that what's going wrong now? Am I wrong? I feel like I'm going in circles. Because the issue, well, you're creating a copy on the stack. The value is in the allocate. Yeah, but we don't need to then load it again. But to use it, you need to load it. Right, and the parameter itself isn't using anything, it just is the thing. So I don't think we actually need to load here, because what does loading an integer 2 actually do? It would create an allocate if we actually lowered this load, right? It would create an allocate and then copy that into there. It would just do this again. It'd create a copy of a copy. I don't see why we need to do this. Maybe I'm incorrect. And then we have a further issue. It would be necessary if anything we're using the IR parameter. It is. It is. Copy 12. This thing. A dereference and a member access. But I think it's only used to store the param value in the right location. Oh yeah, well there you oh. Oh yeah, well there you go. What do you mean, there you go? We don't need to, we already have a copy code. Look, we already allocate and store. Why do we need to allocate and store an allocated and stored thing? Sirraide says, okay, think for a second. I've thought for a second. I still don't get it. Why do we need to create an allocate of an allocate and just keep storing? And this allocate is actually just from 2 registers. Like, if you don't load 6 into 10, how is the store supposed to know how to store 10 into 12? Because it would be storing, it would be a mem copy. It doesn't need to do that. This doesn't need to happen. That's what I'm saying. When we cogen a parameter, we cogen its L value, and then we cogen the store into it. But this means that we already have done the allocate and we've already omitted this copy and already handled it. So this isn't needed now. We need to replace all of these and not do these. Do you see what I'm saying? Like, parameter is not in register, but parameter is not in register. It's gonna require stupid specific handling in codegen.c. It's so annoying. I feel like we should just nuke this API. So you're saying that the second copy is being emitted as part of the parameter lowering? No. It's not. The first copy is needed, and that's what's emitted by the parameter lowering. We need this thing. Okay? We need this. I don't think we need this, because we don't need to mem copy an alloc into a new alloc, which is what this load would do if it were lowered. Second of all, we don't need these, because why do we need to alloc an alloc? We already have a fucking alloc that refers to the thing. We don't need to copy it. So all of this can go. And then when we actually copy 12, this needs to be copy 6. That's all I got. SysV sucks so much. Windows API sucks as well, but at least it's simpler. So how do we know either way higher up before in CodeGen we don't emit this stuff? Somehow. Like, how do we know not to emit this stuff? It is in a register, so do we not make a copy of it? I guess we don't make a copy of it on the stack. Or we need to handle like sys5 stuff lowering here, which is bananas, right? It seems so messy. I don't know what to do here. Sirraide says, you're explaining this in a very roundabout manner. But what I'm gathering is that parameter loading is working as intended. The first load, strictly speaking, probably isn't necessary due to how the compiler works. Yep. And the second store is happening in CodeGen function. My answer to that would be leave it. It's for the optimizer to remove all that. I'm pretty sure, 1, the optimizer runs before lowering, so that's not a possibility. 2, this doesn't work. What are you talking about? Leave it. It doesn't work. We can't leave it. I would leave it. If it was working, I'd go, oh, Pog, we got 69 out. And I'd go, well, it's not ideal, but we'll fix it. It's not like that. It doesn't work. Why doesn't it work? Because you can't load an array. You can't load something that's 16 bytes and assume it goes in a register. And if we lower this load, it'll just create another alloc. And then we store into that. And then this store will then have to be lowered into another mem copy. It's like it's like we're gonna end up with 18 fucking copies. It's not the proper way to do things. Why would I just keep trying to let's make it worse and make it work in a bad way? That doesn't make any sense. It doesn't, it's not, we shouldn't copy something 18 times. I don't like the lazy solution. And I still don't see how these would be removed or removable. with this complex, like, how are you going to say, oh yeah, these 8 instructions pattern match into a mem copy of 16 bytes, so we can remove, you can't optimize this stuff. And it's not dead code, it's all being used because it's all changed together. It's all chained together. It's all fucked. So stupid. Doesn't do anything. Why? Ugh. Why doesn't this get lowered? Next time someone says some bullshit about Windows being worse, I'm going to send them this whole fucking video. Say, look at how awful your stupid shit is. This sucks. It's so complicated. Is this really worth your 5% of performance? Jesus. So what's the lazy solution? What do? I still don't know how to fix it in the lazy solution. You're saying just add another allocate. What does that mean? Where? How? It doesn't make any sense. It just doesn't work. I hate calling conventions so much. Can't just fucking make it simple? Say, they go on the stack if it's larger than 8 bytes. So no, you gotta do this stupid shit. A load of 16 bytes should just work. How? Where should it load it to? Each IR instruction refers to a hardware register. Which hardware? General purpose hardware register on x86-64, the 8-byte architecture, would you like to load those 16 bytes into? Array-215, thank you so much for the follow. Just curious, Sirraide. Why wouldn't this work? If it can't go in a register, it needs to be spilled, so in this case you'd have to create an allocate and copy into that. You mean the thing we just did? What are you talking about? What are you talking about? You're like, you know how you create an allocate and then store into it? Why not just do it again right after? I don't get what you're saying. You may make sense. You may be right. I just don't understand it. It's truthfully baffling to me. I just keep getting told, just make another allocate after the allocate and, you know, for the same thing. Yep, and then copy it. Yep, copy the chain forward. Like, what is happening? How is it completely unrelated? It refers to the same data, and then you're copying the data you copied into the old one into the new one. I just don't get it. This is backwards. Store into 11.6. 11 is a pointer to integer 2. 6. Pointer to integer 2. That's not going to work. We're going to store the actual pointer. into the first 8 bytes allocated here. Fun. So this can't be a store into. This would have to be a mem copy. Or store underlying. Do I have store underlying? How could I do this? Ugh. And really, whenever you load something more than 16 bytes, you have to put it on the stack since it can't go in a register. Do you mean 8 bytes? And by unrelated, I mean that lowering a register to a local variable and loading something that is larger than 8 bytes are unrelated concepts. The load just happens to be from that same local variable in this case. I have no idea what you're on about. You're like, let's make 4 locals for one array. I don't get it. I have no idea what's happening. Yeah. I meant more than 8 bytes, yes. I do believe that the only way to be happy is to ignore how the world truthfully is. Because the world doesn't allow happiness. So we're just copying a pointer, but we need this to be a store underlying. But we only know this to be a store underlying when. You're a sniper. Isn't SysV ABI have support for 128-bit integers that have to be stored across 2 registers? That's actually what we're dealing with right now. It's a bunch of stupid shit. What's the difference between 128-bit integers and 128-bit ints, Sirraide? You were correcting yourself. Whereas I figured you were correcting Eurosniper, who just said 128-bit integers. You said 128-bit registers and meant 128-bit ints. That makes more sense. What is this doing? Why are we not annotating code? We have an allocate 16. We store into that racks. We move 8 into racks. We add RDX into racks. RDX contains allocate. Move RCX into racks, which should now have 8 plus RDX, which is allocate. So that seems fine. We can now lower 2-byte parameters passed to us through the SysV ABI. But then we can't use them. We allocate another fucking array, and then we try and move into that. Yeah, this is just a mess. Just a mess. Because that store instruction doesn't retain it for some reason. So this doesn't work at all. So that's fun. So it appears that it's just the machinery that's broken. That's fun. We don't want to allocate and store here, which would mean that codegen function, fuck's sake, can't do this. So, Sirraide, how do we, even if it can do this, right? Even if it can, how do we deal with this? How do we deal with these being here and them being used? How do we make this store so the thing that we actually have to replace uses with is what? Is it, like you were saying, is it a load? But if it's a load, we have to, like, I don't even get it. I don't get it. This store can't exist. Because it doesn't matter what this operand is, this is fucked. Right? Am I crazy? Let's say it is a load like we had before. Sure, why not? We do that. Okay, basically the problem here is like 3 problems at once. Yeah, I could have told you that. So we can't load an integer 2. Why not? We call lower fucking load on the thing, and if it's greater than max register size, guess what? We create an allocate and we emit a memcopy into it, and then we remove the instruction that we were after replacing its uses. This is done in such a weird fucking order. But when we call lower load, it's just not doing anything. Why? Is instruction type not set properly? It's pissing me off a little bit. We call lower load, it should create a fucking mem copy. It shouldn't do this shit. Yeah? Sorry, it says actually, or do you want to call because I feel like it might be easier to discuss that way? Yeah, I have to find my headphones. But yeah, the load not being lowered is weird. Just so you know, I probably only have like 20, 30 minutes. Let me go grab my headphones. Ah, shit. Okay. Where's my audio cable? Where's my audio cable? It's underneath everything. The classic. Really gotta fix that. Jesus Christ. End up pulling out. Sorry, it says sure. Okay, what am I doing? Can I hear things? That's step one, I guess. Whoop. Make sure I don't leak DMs. That thing. Sure. Did we do it?
Hello?
Hello, I can hear you.
Hello, okay, that's good.
Fantastic.
Right. Do you want to share your screen again, maybe? Or otherwise the stream delay might mess things up a bit.
Oh yeah, I'm trying to figure it out. Okay.
Okay, so basically my understanding of what's going on here is we're already lowering the parameter correctly, right? We are converting it to a local variable. So that's working.
Yes.
Why the load isn't being lowered correctly, that's weird. You're right, that should be a mem copy. And the reason why I'm saying that we kind of need a load here is the following. What is an IR parameter? It's the parameter value that's passed in the register, right? It's not a local variable, it's not anything like that, it's the value of the parameter itself. So therefore, if anything in the function uses the IR parameter itself, then the IR parameter has to be replaced in such a way that the instruction using it still ends up using the value that's passed in. And in that case, that's the entire array.
I now understand. Thank you.
The question is whether this load is really necessary, because is there anything that's actually using the IR parameter? There's one thing, and it's sometimes used like the variable references that refer to an IR parameter, but that's only if it's a thing that's passed on the stack, which this isn't. So is there really anything that uses the IR parameter? I'm not sure, but if there is, then we need to emit a load for it. So whether or not the load is necessary with how the compiler works, I'm not sure about this right now, but in general, the IR parameter still has to be there somehow if there's anything that's using it.
So what you're saying is, correct me if I'm wrong, the things that are using the IR parameter before it's lowered, aka this store, right?
This store doesn't count because that's being emitted in cogen function. So basically the problem that we're having is that we're trying to create this local variable twice. Once in cogen function, and that just tries storing the parameter into it like we would usually do. But then we go to lower the parameter and we kind of generate a local variable for it again. So in the sense, the only thing that's actually using the value of the parameter is the original code that we inserted to lower the parameter to a variable. But yeah, it gets messy because we're lowering it twice.
What you're
And we
saying
might
is,
only need the load right now because we're lowering it twice. If we could get rid of probably the first one in cogen function somehow, we might not even need the load. because if I recall correctly, there's nothing that can really use an IO parameter to begin with, because what we do immediately is we create a local variable for it. So anything that uses the if you have a function that takes a parameter x, anything that uses x in that function will actually use the variable x that gets created for the parameter. And there's no real way in code to access the parameter value directly, except in code that's generated by the compiler to store the initial parameter value in a local variable. So if we write that code correctly, we might not even have to load it at all.
Interesting.
Can you now
So
see why I wanted to call about this? Because explaining this in a message is a bit complicated.
it would be very complicated. So the fact is, this basically just cares that parameter is not on stack, because then we
Yeah,
need to
that's
allocate it on
currently,
the stack.
yes, that's what it's doing currently, but that isn't sufficient, unfortunately. We also need to check that it's not passed in two registers. So this just handles the case of it being one register.
So would this work? Because what are we doing here? I don't think we can do this because
No, we need to do neither of these because we have three ways of loading parameters now. If the parameter is passed in a register, we only have the value and we need to allocate space for it to behave like a variable. If it's passed on the stack, then there already is a variable in the call, so we can just reuse that. But if it's passed in two registers, then it's kind of neither. We can't just simply store it into it because we need to extract it from the separate registers and we'll kind of paste it together into a local variable. So that's a third way of lowering a parameter. So we kind of need to only do one of these, and we must only do one of these, really. Otherwise, things kind of break as they are now.
okay, which is not ideal. You're a sniper, Gabriela Pasantos. Thank you so much for the follows. What am I doing? So we have this copy, allocate, store into. These all look right.
You know, what might make sense for this, especially considering that some targets don't need lowering at all. Like if we have
Right.
a mid-WASM or something, it might just make sense to take out the code that's inside that loop in codegen function and just call a target-dependent codegen parameter. Because parameters are kind of target-dependent. So, no, I think we can still make. I mean, sure, we could also just codegen all the parameters in, or just replace the loop body. Either way works. But what I'm saying is we might have to do that in a target-dependent manner because, well, we do have to do it in a target-dependent manner. So sometimes we
So
need to make a variable, sometimes we don't, and that depends on the target.
so how would this change if it's in the back end?
It wouldn't change too much. The main thing that would change is that when we call this function, we immediately do all of these computations, like determining what parameters go where. And then according to that information, we lower the parameters either by making a local variable, reusing them what already exists, or making a local and collecting all the parts of the thing that are passed in different registers and piecing it back together. So these two branches, as well as the third branch, which deals with things that are passed in two registers, would have to be implemented in the backend.
Which I think makes sense. So to make this backend dependent. Sure. Is that an A?
It's an E, unless you're French.
Okay. So why are we not emitting this load?
What do you mean? What?
Are we not emitting? Why are we not lowering it? And we're
Oh,
not emitting it either.
that is a good question. It should be lowered because even if we emit the parameter twice, that's not particularly good, because as you were saying, we do end up creating two things, and only one of them will really be used. But it would work if the compiler were capable of lowering it correctly, which for some reason it isn't.
But we're not even getting here.
Interesting. Well, this is for register class memory. Does this count as memory?
You're right. It's here. Back. We still call lower load, do we not? No, we don't. Okay, that would make a lot of sense then. God damn it. God damn it.
I feel like lower load should probably be called implicitly as soon as we encounter something that doesn't fit in a register. But that can be like a to-do or something, or if it's
It can't, because it needs registers allocated, so this all has to happen during lowering before register allocation.
I see.
Because memcopy.
I see, and because of the way that it is right now, it's kind of happening after in between lowering, so yeah. If we did that at code gen time instead, then the lower load would be automatic. I see. But that doesn't look right.
It's definitely not right. Array-param. What are we doing? We should just be dereferencing the pointer. So we get a thing
this
to
on
register.
Linux? Or what does this do? Is it just return? It should return 69, right? So
Yes.
okay.
So we do the copying thing.
Mm-hmm.
We load it.
That's that. Yeah.
We load the parameter. We copy 21, which is the loaded parameter. We load 31, which is the copied pointer to integer. And then we return that. So 21, 23, 24, 24 is load 22. 22 is copy 10. 10 is allocate 16. So what's in the first 8 bytes of this? We have copy 10, store into 12, 13. 13 is load 11. 11 is copy 6. 6 is allocate 16.
So this is kind of scuffed, because what's happening here is that the lowering pass that takes care of the two registers creates a local variable, and then the codegen function code takes the value of that thing, creates another variable, and then that second variable is actually used in the function. At least that's what looks like to me.
And then dereference is also making another local copy.
Naturally. Because that would be a load, yes? That makes sense. And then we do... Wait, no, actually. It would be a load of just 8 bytes, so that shouldn't make a copy. Right?
That is interesting. It's this store into... We have so many copies. This is a mess. Yeah. Sort of 29, 30, 29 as 23, 28, 23 copy 21, 21 allocate 16. So after reference array, what do we actually have? So you can see that that's reference array. Everything before reference array is parameter lowering.
I see.
And parameter lowering has caused
all of this.
Lots of things to happen. But yeah, we actually do end up with, somehow, this integer dereference ends up needing to copy the whole thing. How does this even work?
Shouldn't.
No. It probably is like some legacy thing to make load work with
Okay, stupid
arrays.
question, but you did recompile, didn't you?
Yes. It's at the beginning of the thing.
I see. Hmm.
This sucks. So this parameter
It is being passed correctly, right? So to the call.
Oh, it's not at all.
Oh, that would do it.
That would definitely do it. Why aren't we hitting a to-do?
If it's greater than argument register count, yeah.
Oh, we use the same one that we do for fucking MSWin.
Well,
okay. We found it.
I would do it. Well, the good news is that the other code looks mostly correct. So if we can fix the actual parameter passing, then that should work.
It'll make 1 million copies. So is this what we need to do?
Well, parameter is in register. Will that return? That will return true if it's in 2, right?
Yes.
Because it is in registers. So we kind of need to like copy the parts of the parameter into the right registers. Well, duh, but we need to detect that we need to do that.
And then which parameter? Because this is a call. So if it has a parameter in a not in a register. Okay, fuck. So on MSWin, this is easy. What do we actually need to do here?
Okay. Yeah, I'd have to check the spec, but I'm pretty sure System 5 doesn't even care if it's the first parameter or not. Like if you have 20 floats and then 4 integers, the 4 integers are still gonna go in registers.
That's annoying. Okay. Is there actually like any registers mentioned here?
There.
Okay.
Oh yeah, that's passing. There we go.
So we need to get the class of each parameter.
Seems like we do, yeah. And then we just, if the class is integer, we just assign a register or several to it, I suppose.
This is instruction call arguments? Or do I want to go over the function type parameters?
Should probably be the parameters because that's based on the wait, hold on. Yeah, that's based on the function signature, not on what's actually there. Which both of these should be the same at this point because otherwise the semantic analyzer is broken.
That means we have to follow. What about we can't do that because we'd have to do. This is annoying. How do I get a pointer to a vector or something?
What do you mean?
I need so if it's a callee instruction, then I'm going to need to do type function, right? So
it's either function or function point, I'm not sure. I think the type will be function. Yeah.
It's a mess. So if instruction call dot is indirect, then we're going to end up with a function. Function type equal to this.
Yeah, well, delete the arrow function at the end, but yeah.
Else it's going to equal.
Yeah, that should be right. I think that should be function underscore type kind, right?
Yes. Thank you. How did I screw that up?
What's function in this? Because of the for each instruction. For each instruction implicitly declares that's a macro that derives over every function, over every block, over every instruction, and it declares three variables called function, block, and instruction.
Oh God.
That's why.
That would be a mess.
Yeah, it is a mess. The alternative is three nested for loops, and the code
That's
being,
also a
in this
mess.
case, 4 spaces further to the right. 8 spaces if it's indented by 4 spaces. So that's why I didn't do that. Or rather, that's why this macro exists. And because I got tired of writing three for loops.
So we don't even need to do this. We need to say classify handle SysV register class %d class. Okay, what do I have? What do I sys5 reg class integer. We don't need to do anything. Well, I guess we do. No, we don't need to do anything if it's smaller, if it's less than or equal to do 8 bytes. So we can say,
Yeah, like it needs to go in the right register.
so this is parameter type. Okay, sure. So if class is reg class integer and type size of parameter type is greater than 8, what do we do?
In that case, we need to go over the type 8 bytes at the time and copy each of those 8 bytes into the next available argument register. Because the standard phrases it, it's a roundabout way of thinking it. It doesn't think of this as one struct parameter. It thinks of it as two integer parameters that just happen to reside in the same aggregate type. But these two parameters are each classified as integer, and thus they're each assigned an argument register, as though they were two consecutive integer parameters.
So what you're saying is I need to move. Where am I loading from? What?
You're loading the first 8 by loading / moving the first 8 bytes of the argument.
So we have to load first 8 byte of the parameter, store first 8 byte of the parameter. Is this how we have to do this?
Yeah.
Or can we store the first 8 byte? Is this first 8 byte already in a register?
Well, in the case where it's a 16-byte thing, or the first half of a 16-byte thing, it's not exactly possible for it to be in a register, right?
Right. So do we have like a pointer to it? What's our pointer to it? Is that the parameter?
If we have the value, then we must have loaded it already. And what happens if we... So it either is in a register if it's smaller, and if it isn't, then loading means we've loaded it into a local variable on the stack. So in that case, it should be a stack variable, I suppose. But there should be a way of doing this in, like...
So we could load an IR register and get an integer, right? Would that break things? 3 Yassine, thanks for the follow.
What we're really lacking is an equivalent to LVM's extract value operation that just takes a struct value and extracts like a byte from it. I don't think we have an instruction that quite captures that. So maybe this requires a new instruction.
I don't think it does. Why would it need a new instruction? What can we not do?
Do we know for sure what the parameter is here?
What do you mean, do we know what it is? It's type,
like
it's IR type?
What kind of instruction it is?
Yeah.
Well, it is. Its IR instruction is a load, but if that gets lower, then what does the load get replaced with? Or is it the load still? Ugh.
This is a call.
Yeah. But the thing is, if we're like passing, so say we have a struct foo that contains 2 integers, right? So it's a 16-bit thing.
Which we
then
do.
Pass foo to the call. What does it do? Well, it loads foo, because if it needs to pass a variable to a function, it will load the variable. What happens if we load a 16-byte thing?
Stack.
All of that. And what is the instruction that the load eventually gets replaced with?
An allocate.
The alloc. Okay. In that case, we should just be able to load from that.
From this parameter.
Yeah, load from that, and then
But that'll give us the whole thing.
Yeah, we need to load the first 8 bytes of it. So the allocer is a pointer, so we can just load the first 8 bytes from it.
Okay. So we need to copy.
That goes in the right argument register.
So we need to copy.
Load that and then copy it into the register, for instance. And maybe add like an assert or something to make sure that the parameter or the argument that the parameter corresponds to is really an allocer.
This isn't right. It's really not right. Because we can't, it's not a pointer. It's only a pointer because we're doing things wrong. Right? We're supposed to pass it in 2 registers. Which means we need to load it into 2 registers.
Yeah, okay, that's okay. You are kind of okay.
Is it the same thing down here?
To separate the ABI from what the compiler spits out. So from the compiler's point of view, if it needs to pass a variable to a function, it will generate a load from that variable. The compiler initially doesn't care how big the thing is; it just assumes I can load this, and the result is an IR value.
Yes.
The result is 12. It assumes and then it passes 12 to the function. The ABI has to deal with getting 12 into the right registers then, but the compiler just says, okay, I load this thing and I pass it to the function, however that works. And that's what the compiler will always generate for this. Therefore, after that, there's a lower load pass, right? That will take this load and convert it to an allocer. Yes. The lower load pass has no idea that this load is going to be used in a call.
True.
So it will always do the same thing, meaning if based on how you explained this, how this lowering works, is that 12 will be replaced with an allocer. So eventually, foo will be after the lower load pass. Foo is now past the allocer right now, right?
Yes.
So now when we lower the call, we need to look at the parameter. We see that, okay, this thing needs to be passed into registers.
And but we know an allocer.
However, I'm explaining this is a bit complicated.
It is.
If the compiler passes a value to a function, then that value is a single IR value, right? It's this 12. But an IR value that is that doesn't fit in the register gets lowered to a variable. So which means if we have something that is passed to a function that is larger than 8 bytes, it must have been lowered to a variable. Therefore, it's always an allocer. Therefore, we can just load from the allocer.
I'm now understanding. So you're not saying create a new alloca and copy this alloca into that.
No, we
You're saying
use the one that was generated during the lowering pass.
right. So all we just need to use this pointer and load. Okay. Thank
And
you.
load the first 8 bytes from it, then the next 8 bytes into the next register, and so on.
Okay. So,
and for now, we
jeez.
assume that it's like aligned and everything, so that we don't have. If we have like a 14-byte thing, then we need to. I mean, then again, everything is word aligned, right? So even if we load an extra 8 bytes, then that's not going to be an out of bounds read unless the pointer is misaligned to begin with. Well, it depends. If it's a char pointer that has an alignment of 1 and we're passing an array of 14 chars to something, and like it has an alignment of 1, so it could be that if we try to load 16, the last of those chars are on a new page, and that causes a page fault and our program seg faults if we try to load 16 things from it instead of 14.
Yes.
So for now, we're just going to assume that a multiple of 8.
Yeah, what I've done.
I'd added to do here for something like that.
That says, okay, in the second 8-byte. In the second 8-byte, we'll get there.
Yeah, because we know that it's at least 8.
8-byte may not be fully 8 bytes.
I'm not sure if it's more than if it exceeds to 8 bytes and the first 8 byte isn't SSE. Yeah, that's a rare case, I think. So generally, we'll only have 2.
So this is going to have to load a copy. Which is the first 8-byte address. And the reason this has to be a copy is so that we can change its type to be something else, which is a T integer. But it's not a T integer. It's a pointer to an integer.
I suppose, yeah. At this point, we've already passed the type checker, so even if happens to be 8 characters and not an integer, we don't particularly care about this. We'll load it as though it were an integer.
Yes. So then we do a load operand of the first. Oop.
Oh, so I think we're a bit late for that one, but someone in chat is saying good night.
Oh, rip. Neutrino2211 says, this is a very 5-head discussion, but I need to rest my 1 head. Good night. Is 1 head. I'm pretty sure I have a half head.
I mean, having to write code of this can very easily make you feel like you have a quarter head or something.
So we load the first 8 bytes. We need to set the copy operand.
Oh, the ABI document even has an example if you go to page 23.
Does it really?
Interesting.
Ah, yes.
Yeah, that's a fairly complicated one, but still.
Such a good example.
Yeah, below that, there's the register location.
This is crazy. This is the example they gave?
Yeah. And the thing is, it gets more complicated once you have doubles because that struct is passed in registers. But
what?
One of them floats, so it...
So a double... Where's D? Oh.
SD is an XMM0, yeah.
I don't like that. I don't like this at all. This is dumb. This shouldn't be how it works. It's really dumb. Like, what if we made it so damn complicated to use any of the fucking functions we generate that it's not even worth it? All of the time that it takes to do all of this bull crap, and the time that has been spent by humanity just dealing with SysV ABI and the complexity of it, we would have saved time. Even it might save 5% off performance of something that runs once a month. That doesn't matter.
Wow. The thing is, though, that even like 1% can be like millions of dollars if you're a big company or something. So generally, I think the reasoning here is, and I think I mentioned it on the Discord already, that yes, it makes it more annoying to implement for compiler writers, but generally, performant programs are considered more important than the happiness of compiler writers.
Which makes no sense. You're basically favoring performance over correctness. Which doesn't make sense.
There's an argument to be made for that. That's a very complicated and long discussion that has a lot of history. I mean, the only thing I have to say is C++ versus Rust. That's basically that, to some extent, or or manual memory management versus GC, and so on and so on. So yeah, there's a point to be made there that C++ definitely tends to optimize a bit too much in some extent, like this entire signed integer wrap being undefined causes a lot of problems, then it causes gains in performance probably. So yeah. But this, I'm not sure I would call this an example of that, because if it's implemented correctly, then it works. And sure, it's a complicated algorithm, but I feel like if you're writing a compiler or maintaining a compiler like GCC and you implement this and it seems to work, then you've probably done it correctly, because it's used to compile so many if GCC can compile itself while using this, then they've probably done it correctly. So I feel like there's not that much of a risk of this being unsafe or something.
There's a very large risk for every new language that implements it.
Or a new language, sure.
So if you're C and you have 50 years of millions of people working on it, sure. Yeah, whatever, they'll fix it and it'll be correct. That's not how the world works. It takes 50 years and millions of people to do that. That doesn't happen.
Yeah, that's the thing. That's the problem with compilers in general. Like a production quality compiler takes years to write, and also like years while being worked on by a lot more people than two people.
I'm not saying what we're creating is like, that's my point, is that why shouldn't two people be able to create something that fits the ABI? Why make it so complex that that's not possible?
Yeah,
it just shuts things off. And what if they just made it so that, structs go on the stack, you lose a tiny bit of performance, which performant code doesn't pass structs on the stack by value. So it's a win-win. Who's passing structs on the stack by value and expecting it to be like the most performant thing?
Oh, that's the main reason why you pass strings as string views, because they're going to be optimized into, or a big reason why. Otherwise, it would be like the discussion of whether to pass string views by value or something would be much harder if it weren't for this. Like, because of how this ABI works, if you're teaching C++, you can just say always pass string views by value and it will work. Because it is the fastest way of passing a string to a function is a string view. That's generally, if you don't know like sometimes, yes, maybe you want to use a const string reference or whatever, but generally if you're not sure, by default pass it as a string view is generally the recommendation, and pass the string view by value because it's faster to pass small things by value, and so on.
I don't like it. It's really stupid. So what is this?
Sure.
What is this operand? Why we need the argument and not the parameter now? So now we have to loop over arguments.
We might have to loop over the arguments after all. And the thing is also that if we get to this point, then Semler should have made sure that the argument types have all been converted to the parameter types. So it might.
But they might be different sizes.
Really?
If you pass a byte.
Yeah, if you pass a byte, it gets implicitly casted to, or casted, my God, passed to an integer. It should be at least.
Which means byte does not equal integer, which means that their types will be different. So we do have to loop over parameters.
The argument with the cast whose type is an integer. At least
we
I
don't,
hope that's what it's doing.
Yeah, that's not how that works.
Okay, but that is how my compiler works, so maybe I'm confusing compilers again. That happens to me all the time.
I can see why.
That's eventually how it should work.
So how do we get an argument? What is the argument of the call?
You might want to iterate over this by like index, and then just grab the equivalent argument / parameter. And the argument should be in call arguments, yeah. I think index is spelled out, yeah. I'd make that a point. It doesn't really matter in this case, but I always feel kind of weird shallow copying structs. And the syntax for each index is a bit unconventional. It's just name, comma, vector, because it's
naturally
implied that it's usize, because indices are usize. Yeah. You need to do, yeah.
Instruction, all arguments.
The good part, I can't seem to form sentences today. It's horrible. Anyway, what I was trying to say is that the good part is once this is done, that's most of it. We still need to do return values, but those are not this bad, I'd say.
They're this bad. They're this bad. We haven't done return values for Microsoft either.
Similarly bad, I suppose, but it's like this is worse because you won't have to you still have to split things, but
are you ready?
It's similarly bad.
Are you ready for me to show you why it's bad?
What? Why?
I'm gonna show you. We'll get there. It's somewhere here. Oh, here it is.
We have one return register right now. Yeah, that's not gonna work.
Nope. It's gonna break everything.
Oh, unfortunately, we just need to quote unquote need to replace return register by return registers depending on the instruction. I mean, we're even passing in the instruction here, so that's not that bad.
Maybe. We'll see how it goes. I feel like that's gonna be a whole thing. Okay, we load a thing. Yeah?
Yeah. Yeah. We're loading a thing and then we're copying the thing. Not really a store, it's more of a copy, but yeah.
Is it a copy?
Well, we need to copy it into a register. So we need quote unquote store it into a register, sure, but that's not an IR store.
Okay.
Because this load, we're loading 8 bytes, so that does fit in a register, so the result will be in a register. We now need to move it in the right register.
Just like we do with a 2 address to 3 address add. Where we do the thing, we get the value, and then we move it into the register with a copy.
Yeah, something like that, basically.
So yeah, and then
I love how the only thing that x87 is used for these days seems to be long doubles. Which, is anyone even using long doubles? I'm sure someone is.
Nobody is using long doubles.
x87 is basically like, that's the old floating point unit that people don't use anymore as far as I know, because it's just slow and forgotten and superseded.
I mean, it's still used. The x87 chip in like part of the CPU is like every time you use XMM or stuff, something like that. That is the
Yeah,
chip
yeah, but
that's working.
not like the x87 instructions and like
Yeah,
the
they're
entire
not
floating
used.
point stack isn't used anymore generally.
Yeah, yeah, yeah. So what register does this need to go in?
The next argument register. So if this is the third argument, then this is the third argument register, and so on. So yeah.
So what you're saying is I have to do like the sys5 argument register index.
Possibly. Is that the function that determines that?
Well, that gets, if you get like parameter 4, then it'll go through parameters 0 through 3, and it'll say 0 takes 1, add 1 to the counter. 0 takes 2 registers, add 2 to the counter.
I see. Okay, good.
Is that how that
That's
works?
Good. That makes sense. Yep.
Function. What is this? What?
By the way, there's this case in the post-merger cleanup, that's 5a. If one of the classes is memory, the whole argument is passed in memory. Well, it's not important for this function, but that can lead to edge cases where, I'm not sure if you've considered that already. It's if you have, let's say, 5 parameters, the first 4 integers. The last one, actually, let's just say 6 parameters. The first 5 are integers. The fifth one is 2 integers, so that's a 16-byte struct. Then that doesn't fit in the argument registers anymore because you've run out of argument registers. So now you instead need to pass the entire thing in memory. You don't like pass half of it in memory, half of it in the registers. Either all of it, if all of it fits in the registers, it goes in the register, otherwise it goes in memory, right?
Yes.
So that's kind of, I'm not sure if you've thought about this case yet, but that's kind of one more thing that you'd have to consider in when it comes to determining whether or not something needs to be split across registers.
Yeah, I didn't do any of that very well at all.
Okay, I mean, it's not that important now, but it might come up at some point, and maybe I'll add like a to-do for it or something, just so we don't forget, because these are like pretty annoying bugs probably if you have to track them down later. And also we have some more messages in chat, it seems.
Calvin Coolidge, did you consider defining your own ABI? No. Calvin Coolidge, you have to implement it if you want to interface with everything else, which is based on SysV ABI.
Yeah.
You're a sniper, knows exactly what's up.
And also because Calvin Coolidge is mentioning Go, that's one problem with Go, that Go FFI is horrible. Like, getting Go to interact with anything else is atrocious, and it's the reason why sometimes people who write Go in code just have to keep writing code in Go because they can't interface with anything else. So yeah, like defining your own ABI isn't really the best of ideas if you want to be able to use other people's code. Let's put it that way. Like all of libc, for instance, and if you want anyone else to be able to use your code.
So this, we
So if
can't
it's a
actually
natively compiled language,
do
you should
this.
probably stick to the ABI or whatever platform you plan to be running on. Otherwise, you're going to make life very hard for yourself and anyone else wants to use it. Sure. What you can do definitely is if it's and that what compilers do all the time is if it's like a non-exported function. If it's only called in this file, we can define whatever ABI we want for it. Like if there's some
We could pass
changes we can make
yeah,
to
10
how
things in
things are
registers.
passed, we can do with it whatever we want. We can inline it, we can pass everything in registers, nothing, whatever. It doesn't matter. Like compilers do that all the time. Like in LLVM, you can choose between like 12 different calling conventions or something. And if it's not exported, it will choose whatever it thinks is best. So sure, you can make up your own ABI for that, but the difference between that and something like the SysV ABIs is that the SysV ABI it's an ABI, it's an interface for communicating with other libraries and programs and whatnot. What you do internally, no one cares about that. If you can think of a more performant ABI than this, then sure, go ahead and use that internally as much as you want. But if you want to communicate with other programs, then you can't do that. Because if anyone just defined their own ABI, no one would be able to communicate with each other. So yeah. And it looks like at least one person in chat is agreeing with me on that.
Yes. Yes, yes.
I'm just make sure we don't miss any messages while you're focused on getting this complicated stuff right.
I don't think I'm going to get it right. There's a lot of problems going on right now. Because here's the thing. An indirect call doesn't have an IR function, which means we can't loop over the parameters, which means we can't figure out which register index we're currently at, which means everything's
close.
broken.
An indirect call still has a function type. It has to, because otherwise our type system, we wouldn't have static typing.
But we take in an IR function here.
So if it's an indirect call, we have a callee instruction or whatever.
Well, yes, but we take an IR function. So we either have to rewrite this right now or just not handle indirect calls.
It takes an IR function. It should probably take a function type instead then, I think.
Which means it just has to take a type pointer and then like check that it's a function.
Yeah, basically. You are right about that. It's not an IR function, but it still has a function type. That's static typing is nice.
So argument register index. Cert. Function kind equals type function.
I think you forgot a semicolon after the assert.
Less. Now when we pass it to this fucker. Cert function kind is equal to type function.
Isn't it nice how much easier this is than Windows?
Yeah, it's so much better. It's amazing. I love it. Makes everything so fucking simple. Why are you not happy?
One thing that it does make simple is explaining how to pass string views in C++, but that's about the end of it. Implementing it is another story.
Parameter.
And you can clearly tell that this was like very much oriented towards C and C++ because it's talking about C arrays and C++ classes with trivial copy constructors.
Yes. They haven't thought about us.
I wonder why.
Because they're rude.
The thing is, now that we have all of this nonsense in place already, if at some point we wanted to add floats, then we've already basically have half of the machinery in place, meaning everything that deals with parameter passing. We just have to add another argument class, and then that's it, or register class. The only thing that would change would be register allocation, but that would just have to allocate different classes of registers separately. Like we could do that in one pass or two passes, but basically, like if it's in a floating point register, it doesn't interfere with any integer registers and vice versa, basically. That's how that would work, I'd assume. So it would be a bit annoying, but adding floats at this point is definitely feasible. Let's put it that way.
That sounds terrifying. I think
Sure.
I may lose my sanity. Jesus. Okay, so have we done this?
Let's see. So we copy the pointer just so we can change the type.
Yes.
Integer pointer. We then load from that and copy it into the right register.
Hopefully.
We then make is that another copy of the pointer? We could just reuse the old one, but I suppose that also works.
Oh yeah, I didn't
Um,
increment the pointer.
that also we need to add to it. We could probably just add to that first pointer and then use whatever the result of the add is.
Okay. So, oh Jesus. What have I done? So left-hand side is going to be whatever our first copy is, which is first 8 byte.
Yep.
Bless. Type is going to be equal to
The
first.
type is, yeah. Actually, you can just do this. Not
Okay.
even create a new type, just reuse it.
Legendary.
And I'd prefer if you set the right-hand side instead of left-hand side twice.
Oh. Oh, so we're gonna need
And I immediate.
I'm not forgetting this time. We're gonna have to insert all these instructions.
Oh yeah, that too. That's a good point.
That should be that.
That should be that. Yeah, that looks about right. And usage marking for good measure. If we do ever add a DC pass after all of this nonsense, we will need that.
Oh, I'm not smart. Okay. That is the right order, right? Mark used.
You put it the wrong way around, so I'm always confused by it. Because in my
user.
Okay, I'm just so used to destination first, source second.
And I'm used to the opposite because of GNU.
For me, it makes sense how string copy works simply because if you want to assign to x, you do x equals y. If it's a string, you do string copy x y, so the destination is on the left always, even if you assign whether you string copy or not. That's why it makes sense to me that the destination is on the left.
That does make a lot of sense. It's just not how my mental model works. I wish it did, because that sounds a lot better. I feel like my mental model is like arrows. It's a linked list.
Yeah, I see how it is. That's why GNU assembly always confuses me because to me it's simply the wrong way around. Especially because with things like sub, especially because in Intel assembly, sub AB is A minus B. But in AT&T assembly, sub BA is A minus B.
That is
So
quite
it's kind
confusing.
of, yeah. And add adds into the right-hand side in AT&T. Yeah, so sub for me is the worst. And like I move, okay, fair enough. There's an argument to be made that destination on the left side, sure, but it might as well make sense to put on the right side. But not for sub. You can't make that argument for sub. I'm sorry. Like you can't tell me that sub AB is B minus A. Like
It's quite confusing, I would agree.
Yeah.
That one isn't intuitive, but move is intuitive. Move becomes like, oh yeah, left to right. Move thing into thing.
Yeah, but assignment is right to left.
But a movement isn't an assignment.
Oh, someone's saying subtract 5 from 10. That's an interesting idea.
Yeah.
Go back to COBOL now. Subtract A from B giving something. That's how you subtract in COBOL. You write out add A to B giving C or whatever, and then the result is stored in C.
So nasty.
And suppose subtract A from 10, sure, but at the same time, if you like in the language in C or any other language, I've never seen a programming language in which subtraction, except for COBOL, in which subtraction is the other way around. It's typically A minus B. Like this is like I feel like arithmetic is one of the most consistent things about or across programming languages rather. Like you can come up with new syntaxes for dereferencing and pointers and declaring or whatnot, but most people would agree that to add two numbers, you put the two side by side and put a plus in between, unless you're Lisp, but Lisp has the excuse that plus is just a function. And Porth has the excuse that that's like
It's just a different notation.
everything. It's completely different. It's also just a function. But in most languages do write a plus b as a plus b. And a minus b as a minus b. So what are we looking at here?
I don't think it worked. I'm not sure what happened. So I said if type size of argument type is less than 8, continue.
Mm-hmm. Oh, you know what? I have an idea.
What's up?
Correct me if I'm wrong. Actually, no, I am wrong. I know that. Never mind. No, like at what point do we do the function argument lowering where we put function arguments in the right registers? Is this after this or before this?
What do you mean where we lower function arguments into the
basically, if we have a call expression or a call instruction rather, there is a pass at some point that inserts copies from the arguments of the call into the right registers, right?
Yes.
Does that get called before all of this nonsense or after?
Pretty sure that's here.
If it's after, then what we could do something rather cursed. Instead of copying into registers, we can just add them as arguments to the call instruction. And
so it
sure,
says for each argument, get the argument, get the result, make a copy into call arguments.data.
So
into where?
Can just do is instead of copying into registers manually, which might not work correctly because of how this would then be lowered. In fact, it won't work correctly. What we can just do is actually replace the argument in the call instruction that is being lowered with the two arguments that we've just created. That is rather cursed and we'll end up with a call that contains more arguments than it actually takes parameters according to its type, but that doesn't matter anymore because we're after type checking now. We don't care about that anymore.
That's a real mess. So what you're saying is we don't need to do all this.
We need to do part of this. We still need to load them, but we don't need to copy them into a register. We still need to load them because we need the values. But instead of copying them into registers, we just remove the argument, the original argument, from the call argument list and insert the new one. And I'm not sure we can do that while we're iterating over it. So, yeah.
So it's easier to just do this.
No, because the problem is, if you do this, then afterwards, when we lower function arguments, it will insert a copy into the register of the original function argument, and it will overwrite all of this. So we need to somehow make it not do that. And the most straightforward way I can think of is just altering the argument list, which is a bit annoying to do because we're iterating over this. But what I suppose we can do is we can collect all the arguments that need to be split this way, then do all the splitting, and then replace them.
How's that going to work recursively?
Well, not sure.
Yeah, I know.
I don't think we need to.
We don't?
Because basically, what I propose is we do exactly this, except that we do sort of two loops. We make a vector of indices, and on the first loop, we just collect the indices of the arguments that need replacing. And we'll store the indexing.
We'd have to do that in a loop.
Yeah, so all of this that we're doing right here, we're going to do that afterwards, once we've collected all the arguments that need to be replaced in this fashion. And then we're going to iterate over that vector in reverse order, obviously. Otherwise, we're going to be invalidating everything. Or we might not even have to do that in reverse order if we just go by the how many parameters we allocate. This is a bit messy. Like, do you get what I'm proposing, more or less? it's a bit. The implementation is messy.
I do understand. I don't think it'll fit the ABI perfectly. I think it would work for most cases, but in the case where you have a struct of 2 integers and then a double, or 2 integers and then a struct with 2 integers, then this would say, oh, the struct needs lowered, but then that would happen, and then you lower it into 2 integers in a struct, but then that struct needs lowered again through this way and needs added to that indices list.
It doesn't work recursively. If you have a struct that contains, you mean a struct that contains 2 integers and another struct?
Yes.
So a struct that's 32 bytes in total.
Sure.
That's not going to be lowered, because if it's 32 bytes, it's not considered for lowering.
But it will be, because you consider each aggregate as each half. You split it into 2 fields, and the 2 fields could be, okay, you have the first 2 8 bytes, and then you have the struct, which can then be split into 2 8 bytes. Isn't that how it works recursively?
You're forgetting about clause 5c. If the size of the aggregate exceeds 2 8 bytes, and unless you have SSE stuff in there, that it gets passed in memory anyway. That's the post-merger step. 5c.
So the only thing that can be split up between registers is a 16-byte aggregate.
Yes, and there's some SSE stuff, but let's not worry about that for now.
Upon encountering a 16-byte aggregate, we can push it into a list of indices. Then we go through that list of indices, and we replace it, each one, with new, with 2 arguments.
2 arguments, sorry, yeah.
And the arguments are what? These instructions we made here. How do we save these?
Are the 2 loads. We don't need the copies anymore. We need the 2 loads just.
Right. How do we save these to then use them later?
We create them later. We don't create them here.
We don't create these loads anymore here.
We do create the loads. We'll create them in the second loop when we loop over the indices. So the first loop just collects the indices. The second loop does all the splitting.
So what you're saying is this stays exactly the same. We just need to add a check that the index that we are on is actually within the list that we gather up here. Like, let's say...
well, I'd make a vector of indices and then iterate over the indices in that vector. That way we know that the things in there need to be split.
Okay.
Or are eligible for splitting, because, again, it depends on how we calculate this, because though you said that your, what's this, register index function, that already takes into account things that need to be split, right?
What? Yes, it does.
Okay, so that will just work then. That's good. 16 bytes don't need split, yeah.
We may have some problems with pointer types being what the argument is, but we actually don't have a pointer because the argument may have been lowered into an alloc, which is then a pointer. So this could just be random.
That's a point, so we need to check the parameter type. Isn't this fun?
No. Not at all.
Yeah, I think we can what we can do is, there you have it, we can iterate over the parameters, collect the indices that way, and then iterate over the arguments and lower them. We no longer need to iterate over them in parallel. Would you look at that? Well, we might do later if we have something that's 14 bytes instead of 16, but let's not worry about that now. Because again, out of bounds, reads, and so on. For now, let's assume everything is a multiple of 8 bytes.
This is an index, which we don't have.
You know, I think we've mentioned this often enough, though, but I'll say it one last time. The fact that we're doing this in C doesn't make it any easier.
No, but the fact that it's so complicated to do in C kind of says more about them than us.
Hmm.
Does this make sense?
If it's integer, you could combine that into an and, but yeah, sure. Like if yeah, well, you need to invert the condition then. If it's like greater than or equal to, but only if it's not. Yeah, if it's greater than no, so not greater than equal, just greater, Yeah, yeah, yeah. Yeah, that looks about right.
Okay. For each usize I in 16 bytes that needs split,
Jesus Christ.
then what?
So then we need to split the argument, and replace that argument. So we know that we can omit these two checks because we know that that's true, otherwise it wouldn't be in the vector. That's one less level of indirection, or rather indentation, that's good.
And we don't need the continue at the end.
Oh, that's also good.
Argument.
We no longer need to classify it either because we should, like, we know what its class is by now. We do need the argument, that's true.
Annoying. Okay.
Yeah. Because the way this works is to allow you to, okay, so that it doesn't shallow copy anything, and two, allows you to modify things. It always gives you a pointer, whether you use for each and for each pointer. That's the reason why for each pointer exists, because it needs to dereference it one sort of. So we're basically emulating iterating over it with quote unquote references, but because we don't have those, we need to use pointers. So the iteration is by reference, if you will. That's why we have for each and for each pointer.
So what now?
What now? We can delete the copies because that's going to be handled by the call lowering stuff. And then we need to remove the parameter and in that location insert, or remove the argument, and in that place insert two new arguments.
Okay. And to do this,
I think we basically need to remove the use and then erase or remove. We can use remove unordered even.
can we use remove unordered?
Does that
That
take
uses
an
element, right? No, that takes an
uses an
index.
index? Takes an index, good. Because what remove unordered does, in case that, I think you've probably figured that out by now, or maybe I've explained it before, but it basically, actually no, we can't use remove unordered. Never mind. Sorry, that's for sets. Because it swaps it with the last element, which
That'll
in
break
decrement,
everything.
which works if it's a set, but in this case it doesn't. My bad. So we do need to use just plain remove, unfortunately. But it works. But a lot of times, if you don't care about the order of these things, you can it's better to use remove unordered because
Yeah.
that doesn't need to shift everything to the left. And then we insert. There should be an insert. If this is an index, then I think it's insert after. Like if we have just removed index 2, that means the third argument is gone, and we need to insert before 2, actually. Yes, I think it's before then.
That's what I was thinking as well.
Yeah. I always need to think about it, whether it's before or after.
Which makes sense.
But yeah,
And what do we need to insert it before? We need
the
vector, element, and before.
before the depending on how we insert it, like if we insert the second one first, that will shift everything to the right, and then we can just insert the first one. Alternatively, we can insert the first one first and then the second one after.
Like this?
That should work, yeah. And what I'd also do is like fix up usage marking, like we need to remove the use and like
How?
add use to below that.
So the instruction has uses or no?
I hope there is an IR remove use. Because doing that manually would suck.
Remove use of what?
Of the argument by the call, the original argument. The one that we remove.
Usee and user. So we want the instruction, the user, to no longer use argument.
And instead it now uses the other two.
Which we now need to say IR add use, right? How do we say mark used? Is that what it is?
Mark used, I think it is, yeah.
So we need to say instruction uses load 1 and load 2.
Mm-hmm.
Okay.
And now we need to be careful because this is a common error that actually I think we can just fix it if we, instead of a for each, if we make this a for each reverse. Because as always, if we replace things in a vector by index, we need to do it in reverse, last index first. Otherwise, if we insert stuff, everything will shift to the right and the indexes will all be invalidated.
Yes.
So I think if you just change it to a for each reverse, it might work.
That would make sense. Why is argreg index not used?
Because
that'll not be used here.
we won't use it here because that will be taken care of somewhere else.
By register allocations.
Okay, let's see if this works. That is not good. 1633. What's that? 1633. Are you initializing the vector? You're not. That's the problem. 16 bytes that needs split needs to be initialized.
Like this?
Otherwise, it will crash horribly because it assumes that it's 0 initialized it.
Well, it generated something.
It's something. Let's take a look at the call instruction if it has 2 arguments.
We got to try it first.
Okay, we got to try it. Well, it seems to have worked. Would you look at that?
It only copies the array 4 times. That's
Well,
not even a joke.
Look at that. Call foo takes 2 things now. Yeah.
That
Would you look at that?
is cursed.
That is simultaneously a very cursed, but also I think the most straightforward way of doing this. And it's less cursed than you might think. Because do you know what Clang does? Clang just changes the function signature. Like if you compile a function that takes the struct
that may be a better idea, man.
Emit LLVMIR, what happens is that instead that function actually takes 2 parameters. And every call has been replaced to take 2 parameters. So you'd have to also replace the function signature and alter every call.
Which we will end up doing anyway.
Yeah, so I suppose we could also change the function signature as well.
Of the called function.
Of the called function.
But we only have to do that
any
once.
Function that is such that it takes parameters that need to be split.
Calling conventions suck. So the real test, what's a calling convention? Like what's libc where we pass a split thing?
Does it have any function that does? Let me think for a second. Is there anything in libc that takes a struct by value?
16 bytes.
Or 16 bytes. I think libc, most of it passes stuff by value or pointers. By pointers. So, it's a good question. Is there anything in all the string functions, strings and pointers? So all of those are out of the window.
It'd have to be like C++, like standard string view.
You could write a C function. You could write a C function yourself and call that.
That's true.
You can just write a little foo.c that takes a struct foo and does stuff with it, I suppose. That can probably even just go in the test directory because I think it only considers .source files, right? At least the Algol framework does. I don't know what the CTOS thing is doing.
I don't think it considers source files at all.
Fascinating.
You know .source? I think it would deal with .int.
Oh my god! Oh, see, this is what I'm saying when I mean too many compilers. .int files, of course. .source on my compilers files. but damn it. My compiler, my testing framework skips non.source files.
Yes.
But yeah, I meant .int files. This is what I get for working on 3 compilers in a month. Anyway, yes, something like that. And then it builds them with 69. Sure, it adds them together or whatnot.
I guess we have to take a value. We can't
We
return
don't
it
want
yet.
to return something, so just add them maybe or something and
So
return that.
fusum.
Fusum, yeah.
Oh, this is not
Yeah, in
intercept.
this language we need to actually write return.
Okay. That's fusum.
And if this works, we can even be fancy and pass 2 fus.
And then we're going to have foo_int. Passing 2 fus is not something anyone thinks about.
But yeah.
That's probably a good idea. What is this? Fusum.
Passed. Foo. Test failed. Foo.
I mean, I use descriptive names only. Whoa.
Integer. Then we need to declare fusum.
Yes, which can just be fusum x integer foo.
Ooh. Oh yeah, does it actually need a name? I don't.
It does still need a name.
Does it?
Yeah,
Did
it's
I
a
not
mess.
change that when I rewrote the parser? Interesting.
I may be wrong about that, but I'm fairly certain. A is a foo. A.x is equal to 40. A.y.
Or 2. Okay,
29.
Sure. And then we can just do this and see if it works.
So we have to compile it.
Link against that though.
Yeah.
Oh. Fascinating. 37. Argument plus I. You're dereferencing that and assigning it to a pointer. That's not right.
This is a vector of pointers.
Is it a vector of pointers?
Yes. First is an IR instruction pointer.
Yeah, a vector of pointers. This is you could also just use the subscript operator. That's why I'm confused, probably.
You want me to do? I see. Just by I.
All right. That's probably why I'm confused.
Like this?
All right, but yes. Okay, now I'm less confused. But it still crashes, so that's still confusing. And it's that. What is that address? That's -1.
That's not -1.
That's an offset of 8 from -1.
Yes.
That's what you get if you add 8 to -1. Why is it -1? What would cause it to be -1?
We've subtracted 8 from 0.
Oh, that makes more sense. Why are we subtracting 8 from 0?
I don't know why it's happening here, but 1637 is just crashing. So this is wrong.
So is I nonsense somehow?
Yeah, absolutely. I don't know. How would it be nonsense? We pushed it here.
For each index. You're not checking warnings probably. Check the warnings. Check warnings. Check warnings and you'll see.
There are none.
Yeah, there are somewhere.
There
should
I
be
promise
somewhere.
you there are none.
Okay, can you recompile and not run the compiler?
That's what I'm doing every time, but
I like not run int C. So that we actually see just the GCC output. There are a lot of warnings. One of them is, let's see what it is. Let's see what it, yeah, can you like pause for a second? I'm trying to find it. I think it's not it. It's further down on 70. What is it?
I'm not seeing anything helpful from these warnings.
You're not seeing it. The problem is we're not dereferencing I. I is an int pointer, not an int. Oh, and in a usize pointer, not a usize. So we need to do star I and push that.
And for
So
each
there should be
index?
for each I is a pointer, and we also need to wait for each index.
It's not a
Ugh.
pointer. What are you talking
And
about?
what's wrong here? That doesn't make sense though.
I know. There's no warnings here.
Okay, that makes it now it makes sense why there are no warnings. And that probably would have been an error, not just a warning, if you tried to convert an integer to a pointer integer. So that's also weird. Huh. We are initializing the vector, so that's not it. There are a bunch of warnings though.
It's
Vector.
insert before.
In conversion to unsigned. Okay,
sorry.
that's a W conversion warning, it seems.
I mean, these are all fucked. Why are these unhappy?
It's some sort of W conversion warning, apparently.
This is a
That
usize.
that wouldn't do a thing because it's already usize. Fascinating. So we seem to be subtracting 8 from 0, but where would we be subtracting here?
That's not even what we're doing. That's just the address. That is segfaulting.
Yeah. Ugh. So we are pushing the index in the previous loop, and then we're accessing it here. Right? Vector push. 16 bytes that need split I. That looks right. We also zero initialize it. That looks right. We iterate over it. That's a for each reverse. So that's now the I is a what's it? It's a pointer now. So that grabs the first argument. That should be right.
Well, this crashes.
This is crashing. Okay, then this is not right. How would this not be right then? It would not be right if there are no arguments to the call, because then it's empty. But then we wouldn't even be here. Yeah, it's a good idea. Let's print whatever this is. Let's print call arguments data maybe as well as the pointer or something. I think it's capital Z instead of capital U
For a usize?
for a usize.
Okay.
I got sick of writing ZU, so I just made it capital Z. But the pointer should be a P, yeah. Okay, let's see what this is. Fascinating. It's what? That's not right. 16. Oh, we have a stack trace here. I just noticed, by the way. I've been taking this for granted all the time. We now have a working stack trace.
WSL, baby.
Okay, 37. Now it's crashing on reading I. Reading I is crashing. Fascinating. Which means that that the pointer we're getting is null or something?
I mean, I
Can
can't.
you print I, the pointer I? Type pointer element is vector data plus vector size minus 1. That should be right though. Unless it's empty, which it isn't. If it's empty.
What if we don't
empty?
push anything? That'll still be -1.
So if it's empty, if vector, sure, do that. No. That you can't do that. Yeah, like this. It has to be like this. Yeah. As well as maybe for each pointer rev as well. But that's a good check. Have we never iterated over anything that was empty before?
Probably not.
Fascinating. Have you for each pointer rev as well? Preferably, yeah.
What did I just do?
Fascinating. Jang off the warners. That's yeah. There we go. Oh, you're aligning it. Yeah, Clang format does that, by the way. I've configured it to why it left aligns it.
That is very cool. I do like the left aligned backslashes.
I think what I'm basically gonna do is I'm just gonna hand you my clang format because I'm not sure if I can really make it any closer to your style. Like the way you format function parameters is definitely not gonna work. The only thing I can do is like break after the opening brace, then all the parameters in separate lines, then break, and then the closing brace in a separate line. Or not brace, but parent, but you know what I mean.
Yeah.
Okay. That's not good.
Not at all.
Fascinating.
Sys
Let's
5
take a look at the
class.
IR for a second. Does that make sense what we have there?
40. Add 0. 4 into 4.
So that's storing the function parameters. Then we load 3, which is the thing we allocated. Oh no, we store into was 3. We do store into 3.
Yes.
Okay.
Foo.
So never mind. That sets up foo.
So this is the second thing of this is 29.
I think that's right. And then we load foo, and then we pass foo to the call. Okay, so the IR looks right. So something else is going wrong. Oh.
This is now failing.
Hold on. Class is invalid. Classify argument, and then it asserts that it classified it correctly. So we need to go to classify argument, apparently. Type canonical, which this should be a struct type then. Type is pointer type array, or type is struct. If size is greater than 32, we return memory. If it's greater than 8, which it is, I hope it is. If it's an array, well, look at that to do. Well, we're only handling arrays right now. That would do it.
That would definitely do it.
So if you, thing is, we can't. I mean, what you could do is instead of a struct foo, you could make an array of 2 ints because that is structurally equivalent to a C struct with 2 ints or with 2 N64Ts. Oh, and maybe if we write to do like that, it would maybe better if we use the like to do macro for to dos like that.
Yeah, that for sure. Sys 5.
Like the other to do check for underlined fields are not that important, but this one maybe it is because we don't need to do that now or today but eventually. So
Classify sys 5 struct type arguments.
yeah, sure.
Hey.
And now we need to compile and actually link it with the C program. Oh well, that's not quite right.
Yeah, we didn't do it right.
Whoa. Okay, it probably crashed there. No, it just took a while. 80. That's fascinating.
Well, it's consistent.
I mean, it is. It's just not what we want. Interesting.
I'm gonna have to go soon. I am doing well.
Sure.
What do I want to do?
Is the code really right? Oh my god.
We'll be fine.
Fusum. We need okay, Fusum and plus 64, push, blah, blah, blah. Grab that, move it around a bit more, move it into a local variable, it seems. Move it back out. Add them. See, this is what GCC spits out, so we're not that bad.
It's true.
It eventually ends up adding them. It pops RBP and does a red queue. Okay, good. So GCC seems to be working. Um, we could also use Clang and like generate LVMIR to see if that works, but I think it is lowering it the expected manner. So what in the world's going on here? We're doing all of this. Ugh. We are pushing every register that's using the function. Yeah, definitely. Oh god. Oh dear. Anyway, we eventually end up moving that into RCX, pop it, move it back, and then return probably. So that part of it is fine. What about this part?
It's a little
Well,
sus. What is Rax? Shouldn't this be RCX?
Let's see. Hold on. Where do we where is the array? Hold on. Where do we load all of this? Where is everything?
What are you
Oh
asking
wait,
about? A?
wait. A. So that's interesting.
Rax. So Rax is the address of A.
Uh-huh.
And it's being used to load both.
Mm-hmm.
That's wrong.
Huh.
We need to add to it, don't we?
We are adding to it, I hope. We are adding. Are you loading from the result of the add?
No.
Well, I would do it. Why did it work earlier then?
I have no clue how it worked earlier.
Fascinating.
Where? What? Okay. It's
Oh
like
dear,
one
too
of
much
these.
stuff. One of these. It did something. It compiled.
Hey.
And it worked. Nice. Now let's try the other one.
Oh my god. What do we try now? What?
The other one, the one that we wrote, the like what was it? The function what we are doing the other one that we tried earlier that worked somehow.
Yes. That was
That one.
array-param.
Array-param.
This thing.
This thing. Oh, because 69 and 420. And if we add them in, okay, hold on.
Ah.
We don't add them, we just return 69.
Yes.
And it works because we pass 69 twice.
Yep.
So maybe this should add them instead, like
that
add
would
35 and 35 or something.
Yes.
That's why it worked, because we weren't even using the second one. Well.
Quite amazing. Where am I?
Too many commands.
GCC.
See, this time you don't even need to link against the thing. No.
Okay.
I think we can commit that.
Bus.
That took a while.
Thank you so much, Sirraide.
Problem.
I only pain control the latest follow kind of sums up what we just went through. Only pain.
There's definitely something. Yeah. But most of parameter passing is done now. There's like 3 things that I'm missing, but one of them is irrelevant. So 2 things really, and that's what if the thing is not exactly 16-bit. And
okay. Can we? I have a question. So that's a problem if we try and load from it, right?
Mm-hmm.
So we could add like an assert here because we know that's going to be a memory error, right?
Yeah. You can add an assert that checks that this parameter that we're replacing is exactly 16 bytes in size.
Okay. So I'll add this here, and then there's a to-do that I'll basically just say not that, but something similar.
Yeah.
So I would like to assert. Go ahead.
Is it clear why that's a problem, by the way? Because I'm not sure I explained that well enough.
Let me try and explain it, then we'll see how much I got. So we have like a bunch of... Okay, that'll work.
Ooh.
Perfect. Imagine that each of these equal signs is a byte, right? This is 16 bytes in between these two brackets. Let's say we don't actually have that many. What we are doing here is we're loading this first 8 bytes, which is like this or something, right?
Mm-hmm.
And then we're loading the second 8 bytes, which is as if we added 8 spaces here. And what will happen if this array isn't long enough is that this byte will be read from. And that's bad.
It's out of bounds. It's bad. Why is it bad exactly?
Basically, where this is allocated may be anywhere. So let's imagine that this is on the stack and that right below it, there's like some bytes that refer to like 42. You'll actually read half of that integer into this value and then store that into somewhere that is also this size. So then wherever you store it, you're also going to be writing one too many, and you're also going to be reading one too many.
Not exactly, because it's going to go in a register, and the register can hold the extra byte.
That's right. This isn't a memory. This isn't memcopy. So effectively, when we read this, it could cause... Okay, so that's why you were talking about aligned addresses earlier. So if this address is 16 byte aligned, then we're fine. We'll never be out of bounds. It's kind of cool. But if this is 1 byte aligned, which it would be if it's a byte array of 14 bytes, this might be at like OX 47. And if you had like an OX 64, not OX, like that, yeah. So what's... Jesus, I'm not smart. So if this was at like 50 and you have 64 bytes in a page, then in your process, you only have the one page mapped for this memory because this is the bounds. And this is the very end of the page. If we then read that 1 byte past the end of the page, we'll cause a page fault.
Yep, which will then cascade into a seg fault because that page is mapped. Correct.
That's right.
That's why we need to check that. That's why alignment matters.
Which is crazy. So we need to assert that the size of the type...
This if it weren't for the fact that I've heard of a very similar bug before. So yeah.
So the argument type and the size of that needs to equal 16. Otherwise, SysV ABI requires multiples of 16 for requires alignment of a multiple of 16 for aggregate types larger than 8 bytes from 8 to 16 bytes inclusive. Exclusive inclusive.
You can just do the interval notation with open paren 8, comma 16.
That's true.
Bracket.
C++ go burr. That's at least where I learned.
Yeah.
Technically, I learned that in like algebra in 7th grade or something.
That's the maths thing, just in general. Yeah.
Yeah. Okay.
The comma instead of the word to, but yes.
And then it would really help if we could print out the type.
Sure. That's yeah, you can just do that. That works because of how our print works.
I hope so.
I said calls print.
That's right. So how can we could test that.
We could add a test for that. Sure.
Tests sys5 not even sys5. We'll just do passing weird byte array.
This, by the way, this is like classical UB because it will do random things. Because not only may it crash sometimes depending on where it's allocated, it may also return random things. Because if you're reading from a page that is technically mapped but not initialized, you might get random values because it's copy and write or whatever. So um, you will get random data and might just segfold. So this is like UB, classic UB, basically.
What do we actually need here?
A byte array of like 14 bytes or whatever, it doesn't matter. You can just click layer one and pass it. It doesn't matter what's in there actually.
And then how many is this? 1 to
It's enough. It
11.
looks like it's would be 10 then. Right? Or 11? Is it 10? It is 11. Yeah, it is
Null
11.
terminator.
Yeah. I just the space. It's like counting is difficult. Okay,
It's
don't
very
at me.
difficult. Counting to 10 might be more difficult than doing like integrals.
I keep saying that I can integrate in better than like subtracting. So subtracting is the worst. I can manage to add stuff, but subtracting is horrible. I can't. I just can't. Like if I need to subtract two-digit numbers, I need to think for like half a minute to make sure I don't drop a 10 somewhere or something. It's horrible. I will say, like differentiating a complicated thing is easier than subtracting two numbers.
0, 1, 2, 3. What is E?
What is what?
The
Oh, E.
value ASCII.
Oh, the ASCII.
What
What's
is
it
it?
like? Is it 102? I think something.
You are
101.
one off. That was impressive.
Yeah, because A is 97.
It was impressive you did that fast.
Lowercase a is 97, and the trick to that is to remember EJOTY, which are the 5th, 10th, 15th, 20th, and 25th letter of the alphabet. If you
That's
know that, you
very
can get to
impressive.
the other ones quickly. So I know that E is the 5th because of that, and 5 plus 97 is 102, but because it's inclusive, it's 101 because it
Interesting.
starts at 97. So it's 97 plus 5. It's 97, 98, 99, 100, 101, and that's 5.
Pointer to integer 2.
Point to integer 2. That's actually right. Because it's now in a locker already. We need
So,
to take the pointee of that.
so the argument type has been updated? What?
Okay. Wait. Yeah, because the argument is okay. So what's happening? This is the lowering, right? The lower load. We loaded the
Yeah.
array, we lowered it to an allocer. The allocer is a pointer to an array. And this is the argument of the parameter.
Ah, yes. So,
Mhm.
okay.
You can either get the parameter or type pointer to.
That's a mess. Yeah. I didn't do the right thing, did I?
That's good.
Well, that doesn't make any sense now. Integer 2 is 16 bytes. Whoop.
Ooh, fascinating.
What
Interesting.
is the size?
Wait, how did that happen? Oh, is it maybe wait, what is the size? That's a good question. What the hell is going on?
Oh,
Oh, well, duh, we're taking size of argument type instead of. I think we need to check the parameter type here because the argument may have been converted to. So the funny thing is that this might actually work because of store. Because I'm pretty sure when you are, what is it? The problem might be even deeper. It might be in lower loads. We need to account for the same problem in there, I think.
which problem? This problem?
Yes, this problem, because if
Okay.
it's creating an array of two integers, that means it's lowering lower loads is working in multiples of 8, isn't it? Because
It
it's a mid-mem copy.
it
A mid-mem
emits
copy. We need to
no,
fix a mid-mem copy, actually, then, I think.
it actually emits like enough 8 bytes and then single bytes.
Really?
Yeah.
What is the type? How much does it allocate on the stack? Does it allocate a multiple of 8 or a byte array?
Memcopy doesn't do anything onto the stack. As for
Lower
allocate,
lower load. Does that?
it just uses byte size, which is type size of type, which could be anything.
Okay.
But then when we emit a copy, yeah, it's the same thing. That's just byte size.
Type is pointed to that. Pointed to type, and type is the type of the instruction. Fascinating.
Yes.
Hold on, is this right? So
We
if we lower a load.
This is what's doing a lot of the work.
I see.
Store
So
underlying.
somewhere in there, something is going wrong. The type's not being assigned correctly, basically.
Yes.
Okay, let's add a to-do about that somewhere, because that's not correct either, because we might run into, okay, memcopy doesn't seem to suffer from the same problem, but the fact that our type system is a bit broken because of it is a bit sus. Okay, now it works. What did you do? Oh, we're just checking for parameter now in the other
Yeah,
function.
I did the other one.
Okay,
Does
but
this...
just in case, add a
Nice.
to-do here, because if we look at 30, what is it? What is it? It's 27, load 26, 16. 16, it allocates 2 integers. So yeah, 16 is the temporary, apparently. So yeah, let's maybe add a note about that might have to be fixed some. Well, I'm not sure if this would be a problem technically, actually, but the type
So
being not byte 11 is weird. That's sus.
there we go. There we go. I think I may have ran the wrong command.
Really?
Oh, I did foo.int.
Oh, well.
That's there's so many. They all look the same.
Okay, that makes
This makes
now
more
it's
sense.
byte 11. Okay, where's the... That's foo. We need to check main. Okay, that's looking better, I think.
Is this even using the calling convention? No, so it's not
Oh,
lowering it.
because it's not lowering it. That's
Okay.
why. That makes sense.
So we kind of screwed ourselves in adding that assert. We now no longer see the lower level assert because
So
we don't get
let's
there.
just copy out the assert to make sure that the rest of the
I did
stack is working.
Where did it go? Here.
Brilliant.
That's a mess. Okay.
I don't even remember the last time I used block comments for. I mean, actually to comment out a section of code show, but I typically don't like type them out manually. I just have a shortcut that comments the region. Is this correct now?
Allocate 11.
Better?
We get 2 byte pointers.
Jesus Christ. Where is the call even?
Load 29. That's...
Ugh. That's in
okay.
foo. That's why.
That's in main. So call foo. 24, 28.
4, 23, 6. And 6 is, drum roll, 6 is, okay, good. I think it's fine then. We just compiled the wrong program. Okay.
I got you with that one.
I think we can add the assert back in and everything is well.
Legendary.
So let's rejoice that we won't have to debug anything in the lower load memcopy part of this thing.
We should probably emit multiple loads. How does this actually work?
Okay.
So if it's not fully 8 bytes, what should we do instead?
Yeah, that's kind of complicated, isn't it?
It's very complicated because how do we read 3 bytes?
Load 5 bytes into a register.
We have to go back 3 bytes, read 8, or do something like that.
Or either that and shift, or we load 4, shift, load 1 into like AL. Or like yeah, but I think going back a few bytes and that's an unaligned load though. But I think
yeah,
on
that's
x86
not good.
fine. On x86, I think unaload lines and loads into GPRs are fine.
It's messy either way.
It's a bit messy then. I mean, loading 4 and then loading 1 is more instructions, but still.
Pog. The test passes.
I do wonder, how does GCC do it? If I declare an array, hold on, let's see. Or do you want to do that? Make a struct that contains a char array of 11 chars. and then pass that. Basically,
That's not
yeah.
the right language.
That and remove the other two, and then just add like the first two elements or something. Or you need a function to pass it to still. Just instead of adding x and y, just add like the first two elements or something, or like the first element and the 10th, so that we actually need to use that.
I'm an idiot.
U.a, so a.a. A don't need to write a.a. Yeah.
I was like, it's A. What is going on? This isn't a member.
Geez. Okay.
Well, that makes me feel better.
Do me a favor and put a -03 on there so that it optimizes this nonsense away, so that reduces it down to what it actually does. So it's doing what I said it would do. I think it's loading from like, oh no, actually okay. We need to like tell it to actually call square, even though it has side effects. So you know what? Better idea, delete the body of square and make that an external function. That way it has to call it. You can't optimize the call away. See, that's the tricks you pick up if you need to force the compiler to actually generate code. So this is how you would call. Fucking Christ. Just another line load. Fascinating.
It just doesn't care.
It alls it out. That's brilliant, I think. It alls it out or something. Or there's also an arithmetic shift in there, so it's doing a lot of nonsense. Brilliant, just GCC, brilliant.
Yeah, we're shifting by 16. It's a real mess.
19, we do a... Okay, fascinating.
Okay, so it's good to see that we're not insane.
Yeah. I think it's using the... Is it using the red zone here or something? It's not even allocating. No, it can't be, but still, something is weird in what it does here.
Yeah, it's just using the stack. Kind of scarily.
Fascinating.
It's like do we need to actually call bar?
No, I don't think that would help. It would just inline it into May. It's at 03, we'll just inline it into May. Oh, now we have a sub queue. There we go, that's a start. Okay, now it actually allocates memory, and it does, Jesus Christ, GCC.
It moves 0 into 5 and 12.
Into offsets 5 and 12.
I don't know what this does.
Does that equate to... my head hurts, I think.
I don't know how these numbers have anything to do with this.
Well, GCC.
Because this is
so anyway, I think from this we can conclude that whatever cursed way we could come up with to implement this cannot be worse than this.
So this moves 4 bytes, 8 bytes, and 4 bytes.
This is added. This is a 4-byte move. That makes more sense. So at offset 5 and into offset 12. That is 12 bytes, isn't it? It just doesn't care, I think. It just allocates 12 bytes or something.
Yep, it's just rounding it up to the nearest round 4. Yeah. Multiple of 4, I would say.
We can just round up allocations and not deal with this nonsense.
Oh.
Ugh. Oh, you know why?
It's just zeroing.
It's just zeroing it. So let's actually put something in there.
Very nice.
Yeah. No, I think even then it will do that. Yeah. It just computes a constant and loads that because it does that. It just figures out that it can initialize all of these at once by loading a constant. But if you set it to 0, the output will be just too much nonsense.
It'll be a little...
No, it still does that. It still moves. You can't get it to not do that, apparently.
And it moves it into -10 off the base pointer.
Yeah.
And then it moves 2 bytes. So it looks like it just rounds it. It just handles it. But in some cases, like in 11, it does 12 instead of...
It does this instead. So -11.
Interesting.
Fascinating.
Yeah, so it looks like we have some way to go in dealing with this.
Again, whatever cursed way we will come up with with for dealing with this cannot be possibly worse than that. So
That's right.
it is generally a problem that requires a horrible solution.
Middle Cloud, hey, hi, how are you? I'm just about to go, but we did so much today. I'm happy. We actually did something. I feel brain dead.
Yeah, it only took 5.5 hours.
That's right. But yes, we have passing weird byte array as a test. Okay, so we have type is struct for AST. We can start with that.
And yeah, what you mentioned is either in Semma or in Codejump, we should probably, in either place, we should canonicalize the types, probably.
That's a good point.
A very easy place to put that would probably be in Semma.
I'm going to do a bunch of sys5 stuff. Actually, I'm going to fix things first.
Again, this is a problem that you don't have in C++ because you can just make size a member function and then it just does all of that automatically. And you can't accidentally get the wrong thing because it doesn't let you access that. So yeah.
It's very true. C++ is way easier to be type safe with more complex types.
That's why I like C++. Like C is just, it shows that it's a 50-year-old language. Let's just put it that way.
I agree. I think one of the main attractors of C++ for me is that it's actually like the type system is so complex that you can almost represent arbitrary data
Type
structures and thinking. Yeah.
Templates are Turing complete.
Exactly. That's exactly what I'm getting at. It feels very cool in that way, but I feel like there needs to be. It's so complex and so far-reaching that it's hard to go back down to simple things. Like, but then how does this relate to adding two numbers? You know what I mean? It's like
the thing for me is simply that I can't really argue against that anymore or for that because I feel like I'm simply too used to C++ at that point so that to where it's not a problem for me anymore. So I can't really argue objectively whether this is whether templates are a simple concept or not because I've just had to deal with them so much that I now can look at the template and know what the compiler spits out. Yeah, basically.
That makes a lot of sense. Because it's the same way, like, when we look at the time, we don't parse it and go, okay, 1, 9, colon.
Same with if you look at C code, you know what the C compiler will spit out. Well, if you do with C, if you program C++ long enough, you know what the C++ compiler will do more or less.
That's right. Okay, geez, that was messy.
Yeah, truly. And again, it's an interesting comment that I read on a blog post about Go is how apparently during the 2009 conference where Go was announced, an audience member asked, "Why did you choose to ignore any research into type systems since the 1970s?" And that kind of summarizes why I like C++, because it very much hasn't. It has very much added many new features that are very useful for representing all sorts of things in a succinct and type-safe manner. Also, Middle Cloud in chat is asking only, and that was probably in reference for me saying, or to me saying that it took us 5.5 hours to implement this.
That's right. Yeah, it only took 5.5 hours to do this. Nothing major. Quick little project. What are we doing? Let's make sure, like, Fibonacci, I guess. I could have ran the tests, is one thing I didn't think about.
Yeah, maybe run the test. That's a good idea. With enable, okay, maybe with C, make sure you can do that. Or with enable testing colors, that's also a thing. Because
how do I do that? Do I have to set?
You have to define an environment. You can check the script. You have to set an environment variable because I didn't want to implement parameter passing yet because that's kind of annoying because with shebangs and whatnot. Because I think there is a way of getting the interpreter to do it, but by default it just thinks that any parameters passed to it are for the interpreter, not for the program.
I see.
And with shebangs, that's kind of a bit complicated. I think there's a way of doing it, but still.
I don't have the
I just
algal suite.
did this. So I just did this because I couldn't be bothered.
This is a mess. Okay.
Well, most of these look right.
It does look pretty good. Overload block always failed.
That was fun. I guess some are still broken. I think what I recently checked my not branch fork.
Yeah.
My fork.
Ugh.
And it's 100 commits or so out of date. 3 commits, Maurice, but there's 3 commits on the latest that you haven't merged, and one of them says fix function pointers. So
that could definitely have something to do with that.
that may be this. I'm not sure if it is, but it may be this.
Oh, middle cloud.
Ooh.
I just linked to a pull request, but that's where the OS code is hosted. That's where you can find the OS.
Most of the recently written OS code is hosted, isn't it?
That's right.
But yeah, it says 3 commits ahead for me, and one of them says fix function pointers and warnings. And it's literally just fixing a bunch of format string warnings, as always. But also, somewhere in there, it does a thing with function pointers. And you can actually, if you want to, just feel free to look at my fork or something and grab that one line of code, paste it in here, see if it works. And if it does, I'll like merge and make a PR or something.
Where is it? Did you just say?
Oh, it's if you hold on. This is the relevant commit.
Oh, nice.
And if you scroll down a bit, and it's in what file is it? It's in source codegen intermediate representation.c. If you go to that file on line, what was 439, it is now 450. No, down a bit. I've changed this, and I think that's the only thing in there pertaining to functions and function pointers. Everything else is just fixing warnings, which is also a good thing, but still. Maybe that fixes it. I don't know. I called this commit fix function pointers. So this was 3 weeks ago, apparently, so I do not remember anything about it.
Is it in what?
It's in II indirect call, apparently.
It looks like it was merged.
Was it? Fascinating.
We have call type, function type, pointer to function return type.
Function type, pointer
and then we
to
assert.
That is right. So apparently that didn't fix anything.
Okay. Good to know.
Good to know. Or maybe it did and something broke again. Who knows? But, well, that's good to know.
That is. Nope. Okay. It's real unhappy.
Jeez. That's
I know.
not nice.
I can't get it to work. I'm just gonna do this.
You know what?
Blink.
Just yeet the shell. Sure.
So on Windows, the confusing part is that things pass.
Fascinating. That is really interesting.
So yeah,
Interesting.
using C-test. So it's just a Linux thing.
Fascinating. Oh, that's really interesting.
Here,
wait, are your Windows and Linux branch the same repository?
It's the same directory.
Yeah, okay, good. Just making sure, like,
that's a good yeah.
I know you are prone to creating copies of your project, so I just wanted to make sure.
That's for sure. Yeah, downwards fun argent doesn't work, and neither does function pointer. So
oh god.
There's something to
We've also
think
got
about there.
some more comments in chat earlier that you missed, I think.
Okay, I'm on it. Sure Shack 55. It is very hard to go back to C++ after writing Rust for years. Maybe. You'll get it. You'll get it. I feel like it's definitely transferable that way.
I guess it also depends how long you've been using C++. I'd say.
That's true. Middle Cloud says maybe end of row. I'm not sure what that means, but you could very well could be right, because I don't have any idea what's going on. I've got to go so bad. Oh no, it's 8. Oh no.
Another message earlier from them that you missed, I think.
Okay. Middle Cloud, at least you worked with C++. My first programming language was BASIC, and I jumped to the mistake language, PHP.
Yeah, PHP.
/n, Linux /r/n. Maybe. I don't think that would have anything to do much with funarg.
Downwards funarg, yeah, that's a bit, unless you're printing a string literal or a new line in downwards funarg, but no.
We're not.
Or
We're just
string
returning 69.
Yeah, that should definitely work.
Yeah, we'll figure it out. I will look at that. But yeah, overall,
Keep in mind that in general, function pointer passing like that may require static chain pointers if you want to actually capture stuff, and then that gets a lot more complicated, just so you know.
Yes.
Just in
Yes.
general. But that's pretty good. 93% is pretty good.
It's very good. And on Windows, it's even higher. 97. So we can say it's above 90% passing tests. You know what I mean?
That's decent, yeah.
That's decent. Anybody who can say that, it's like, you're not doing too bad. Beautiful. This is a mess.
Jeez.
So,
We're still not quite done with this, though, I think.
Yeah, no.
What is the stack parameters isn't really that accurate anymore.
No.
It's more than just that. It's just general
Parameters is hard.
Parameters is hard, fair enough.
Eventually, it'll be called ABIs is hard, okay? Because we'll do return values next.
Oh, yeah.
After I work on the OS some more, probably tomorrow.
That's a good idea, probably.
Yes,
Take a break from all of this nonsense.
I do want to show. I probably can't very easily.
It's fascinating if the OS is now the project that's more pleasant and simpler to work on.
It is working towards that, which is very scary.
I mean, you can always, if you want to, you could definitely rewrite the shell in C++, you know?
We can now.
We can now, exactly, yeah.
Because we can now add a CXX user space program.
Which is nice.
Yes.
Because we have an entire standard library that we would otherwise not be using.
Yes. But yeah, we actually can use libstandard C++ now in, for example, Echo.
Work, by the way, and why did libc even compile then earlier? Because libc uses C++ profusely. Why did that even compile, but the user space program didn't, when libc is also a user space program?
Great question. That's actually a really great question that has to do with GCC and G++. Basically, in libc, in the CMake, what we pass as one of the compile options is no standard lib and no standard include.
Yeah, I know.
Which,
That's pretty much, I think.
If you're like me and you picture C first, all this means is you don't link with libc.
Yeah, well,
but
it's also libc++, I'm pretty sure.
Yes, there's also libc++, and I didn't think about that. So libm and libstandard C++, if you don't pass these two, are linked with by default by G++.
Yeah, G++ link. I didn't know what libm, but I did know that G++ is basically GCC plus set the language to C++ plus link with LSTD C++.
Yes.
I didn't know about libm though, because if I'm not sure if you've ever tried it, but if you try compiling C++ code with GCC, it will fail because if you can't, it won't link against libstd C++.
Which is exactly the sort of errors we were getting, but it was actually that it can't find libstandard C++. So for it to actually find those, we just had to implement them. So now we have libm and libstandard C++.
Which I'm sure contain a lot of code.
Yes, tons. There's nothing in either of them.
File system exists as a function. Oh,
Yeah, we
nice.
did it.
It's not implemented in the class anymore. Ooh, just so we have anything in there.
It's true. But now, for example, in Echo, it uses standard print in user space and everything works great.
Oh, and just because I just saw that now I have to comment on that. You can do namespace standard : file system.
I got a warning about that.
Yeah, because that's C 17, but you need to like tell
But
it
that
to
doesn't-
compile C20, but that's fine.
Which it doesn't make sense because we have in the top level CMake, we set the CMake.
I don't know what
don't.
warning you got, but that is perfectly valid C++. So that
It's just-
warning is bogus.
Yeah, it has to do with where I'm setting the standard because we were setting it at the top level, but apparently we aren't here anymore.
Either way, you can do that just so you know.
But yeah, things are going so much better in the OS, and the compiler is getting nonsensical in its complexity, but it is going well.
Eventually, we're gonna port the compiler to the OS, and then that's gonna be fun.
That is definitely going to be something. The interesting thing is that porting the compiler is going to be not that difficult.
Yeah, we only need a few functions. That's true.
That's because there's no third-party dependencies. It's like, just build it.
That's true. That's true.
Because we already have the cross compiler. We might already be able to do it.
I mean, there's two things that are missing. One, probably a few libc functions that we just forgot about. Sort of.
Yes, for Gore.
Two, creating files and writing to the file system, because I'm pretty sure we can't do that.
Oh yeah. That might be an issue.
Can't actually make any permanent changes in the OS itself. That's
Well, you can use pipes. You can use pipes.
You can use pipes and just pipe the program to standard output.
We'll use a pipe, and we'll just open the pipe, write to one end, read to one end.
From the pipe and like pass it to a function pointer and execute it, or what? Or like, no, we need to like load from that then somehow. So we need to like
fork.
No, how can we exec into something that's in memory though? That's not how this works.
I mean, we can write it.
And add a syscall that execs into a user space buffer. Sure. Jesus Christ. I mean, the functionality is there in kernel space, but still, we'd have to. We'd have to run the compiler in the kernel, because the kernel can just exec into random memory.
That's right. Very easy. That'll be great. And then we'll make it JIT.
Oh yeah,
just in time.
make it JIT.
Okay, I gotta do this badly. I had a great time today.
Okay, once I'm done with this, mostly done, if I want to take a break from the web server and have some time, I might take a look at adding an LVM backend or something.
That would be legendary. Because it would help us ensure correctness and see how it's done. Like, what's the IR that's generated for LLVM versus ours?
You at least run Clang on your system, by the way.
I do have a working Clang.
Okay, that's a start, because otherwise you wouldn't have a working Clang format either. What version? 15! Would you look at that, the most recent even. So
Hey.
that's nice. Good.
Alrighty. That's been great. Thank you so much, everybody, for watching. We implemented passing structs, not even structs, passing arrays on the stack for SysV. And also in registers.
Across into registers.
Yes, which is horrible. Luckily, we've done it. We have done it, and now it works. So, yeah, we've got passing tests, we've got failing tests, we got stuff to do, we got stuff we've done. Would you like to point people anywhere? Do you got links? Do you got things?
None that I can think of, but check out the Discord.
Perfect. I like it. I like it. I love the plug for the Discord. Definitely check it out. There are announcements. Oh, leaking DMs. I'm great at that. There are announcements every time I go live. Be sure to check this out. As well as, just come say hi. We like waving at you. We like saying memes. We like... Do you say memes? Do you post memes?
saying memes isn't. You say images, typically not.
I see. So we meme all over the place.
Posting memes is typically posting memes, yes.
Middle Cloud says, QQ, is it compatible with WSL? Yeah, that's actually where, what is what compatible? If you're asking about the OS is built from WSL or from Windows. Either one is possible. There's a Windows toolchain and a Linux toolchain.
Can you run Clang on Windows on your system?
Yes.
Okay, that's good.
This XA PC Windows MSVC.
Oh, I didn't look at that. Yeah.
It's fair. I'm jumping between terminals. Shells. One terminal.
Correct.
I did it. Hey. And on that bombshell. Sorry, I had to do Clarkson. That's it. Oh no. Thank you so much, Middle Cloud. Shout out Middle Cloud also. Thank you so much for tuning in. Check out the VOD if you want to see any more stuff like this, and the YouTube if you want to check out previous VODs. And Middle Cloud, shout out to them. They're the most recent contributor to the channel. Thank you so much. We love you around here. You're keeping this thing going, letting these streams happen more often. You got 3 streams in a row. It's almost a rarity. I don't think it's ever happened before. But yeah, I am glad. I just thank you all for watching. Go check out the description. There's a bunch of links to GitHub, Codeberg, and PayPal, and to Sirraide's Patreon, and to all sorts of things. The compiler. Go check it out. Go check it out. Start. Download it. Fork it. Do things. PRs. Oh. Bye-bye.
Ta-da.